Hello everyone, it's nice to see you all here. I hope that you can hear me. We will start in 5 minutes. All right. Hello, everyone, and welcome to day 1.5 of the WikidataCon. I hope you're all doing well. I hope you found your way through GatherTown, or maybe you're watching on YouTube right now. Um, and I hope you're ready to enjoy the exciting program that we have in front of us. So I don't know if some of you maybe already attended the first part of the conference that was broadcasted directly from the University of Taipei, where our friends from the Wikidata Taiwan community and Wikimedia Taiwan have been running a really nice program highlighting the projects run in the Easy App region around Wikidata. If you missed it, that's fine because you can find everything in replay on the YouTube channel of Wikidata Taiwan. So I would say let's get started right away so we can enjoy this conference. So in case you're wondering where to find information about the conference, you can find everything on wikidatacon.org that will lead you to the related wiki page. If you're looking for the schedule, you can just type program.wikidatacon.org and you will find the schedule. We'll go back to this in a minute. If you need any help at any point during the event, feel free to reach out to us at contact@wikidatacon.org. And if you're posting on any social media, you can use the hashtag WikidataCon. So I guess that most of you are watching this on GatherTown. This is this nice platform that we are using as our virtual space. If you're watching us on YouTube, you can also watch the whole conference on YouTube. But if you want to interact with people, we advise you to follow us on GatherTown. If you're not registered yet, you can still register for the conference, and then we will allow you to enter GatherTown. You will receive an email with the link and everything you need. So you will notice that the program is full of breaks, some little breaks that you can use either to talk to each other or maybe to stand up and take some fresh air and have a little bit of a break. And there would be also longer breaks for example, for you to go for a walk or eat something or drink water as you please. And we, of course, encourage you to not stay stuck to the screen during the upcoming 8 hours. Feel free to take a little break from the screen from time to time. And as you probably noticed, you all have some little avatars. You can walk around, not only in the room, but also outside of the room. You can explore a little bit the GatherTown platform and then interact with other people on the way. So as a reminder, this event is covered by the Wikimedia Universal Code of Conduct. We kindly ask you to encourage a positive and constructive atmosphere and to respect people's privacy and anonymity. So for example, use the name or the username that people display here and do not disclose any kind of personal information. We're in a virtual space, but we're still very careful about the image. So if you want to take screenshots or things like this, make sure you have consent of people, especially if you want to publish these pictures later. Don't hesitate to ask for help, and also don't hesitate to help others if you see people having questions in the chat, for example. And of course, no harassment, personal attacks, or violence will be tolerated. So as I was saying, you can access the program on pre-talks through program.wikidatacon.org. It has a lot of nice features, and one of them is that the schedule is automatically displayed in your local time zone. You can also switch from the official event time zone, which is the Taipei time zone, to your own time zone. And if you're missing a session, don't worry, because the whole event is streamed directly on YouTube. You at the end of each part of the event, so day 1.5, day 2, and so on, the entire video will be available on YouTube, so you can just find the session that you've been missing and watching as you please. So here's what the schedule looks like very quickly. We're gonna have plenty of very interesting sessions today. We're gonna have just after this one, Wikidata, what happened over the past year. I just wanted to inform you that the session that you see at the bottom left of the screen, batch validated Wikidata items using entity schema, has actually been cancelled, but we hope to reschedule this session very soon at a future event that's going to come in November. That's called the Data Modeling Days. And then after the break, we're going to have a lot of other very exciting sessions. But you can find them directly on the schedule, and you can also see them at your local time zone. This is my time zone display right now. All right, so let's talk about languages. So the sessions of day 1.5 and day 2.5, which are the international online parts of the conference, are taking place in English. Some sessions are actually pre-recorded videos, so it will include captions in English and traditional Chinese, which are the two kind of official languages of the conference. And we also offer translated live captions. This is, I have to say, kind of an experimental tool, so you will certainly notice a few glitches, maybe on the very specific Wikidata vocabulary that we use, so be kind with the AI, it doesn't know everything just yet. Now, as you all know, the WikidataCon is the occasion to celebrate Wikidata's birthday and to share presents with each other and to celebrate the achievement of the community. So there is this page that you can use to see information about the birthday, also see the other events that people have been organizing during the birthday. You can leave a message there. You can leave a present, which is one of the traditions of the community for the birthday. And tomorrow, during day 2.5, we will have the birthday present lightning talk session, which is also a tradition of the WikidataCon. So if you prepared a present for Wikidata for the community, you can still add it to the list and you can present during the lightning talk session. You just have to go to the Etherpad that I just linked in the GatherTown chat, and you can add your session here. Feel free to do it as soon as possible. At least book your slot. You don't have to spoil the title of your present and everything, but add yourself here so we know that you're going to present something. You can also find all of the details in the description of the lightning talk session. All right, I think that's all for me. So I hope that you have a great WikidataCon. I hope you enjoy the day 1.5. And just in a few minutes, we're going to hand over to Lydia for another tradition of the WikidataCon, which is Wikidata, what happened over the past years and what's next. If you have any questions, feel free to ask in the chat or feel free to contact the organizers at contact@wikidatacon.org, and see you around.
So hi everyone, I'm Anne Cazzellini. I'm here as the facilitator for this session, and please welcome here our dear Lydia Pincher for the session, What Happened Over the Past Year and What's Next. Feel free to send your questions to the chat. I'll be going through them by the end of the session, and also feel free to raise your hand and we can go through your questions by the end of the session as well. So Lydia, the floor is yours.
Thank you so much. Thank you so much, everyone, for coming. It's so great to see many of you again, and also new faces. This is a session to look at a bit of what happened over the past year around Wikidata and what's coming up. It is because I'm doing it slightly slanted towards developer things, but I hope to cover more than just that. So let's get started. Where are we today with Wikidata? So this is Wikidata today, or at least the items on Wikidata that have a geocoordinate. And every time I look at it, I marvel at it because it took a tremendous amount of work to get all of this data into Wikidata and collect it. And at the same time, it also shows how much more there's left to do. And I hope many of you help us make this map light up even more in the future. So let's look at community. Today, we have about 12,200 active editors. So this is people who make at least 5 edits a day. And of those, we have 3,000 people who make at least 100 edits in 30 days. So love to, especially you. Thank you for being a part of Wikidata. On Wikidata, we are at the moment at a pretty mind-blowing 20 million edits per month. And over the whole lifetime of Wikidata, we're closing in on 2 billion edits, not too far in the future, which is a lot. One of the things that I thought was really, really cool this year was the awarding of the Wikimedian of the Year and Wikimedia Laureate to Taufik and Joanne from our community. And it is a great recognition, I think, both for them, but also for the Wikidata community as a whole inside the Wikimedia movement, to show what we all do for the Wikimedia movement. So consider part of these awards also yours. In terms of content, today we have about 106 million items, and on average they have about 14 statements on them. And not quite the same ballpark, but also growing nice and steadily are Lexemes, and we have about 1.18 million of them now. So we're reaching a size where you can actually build meaningful applications on top of it. And next to that, we have about 11,000 properties. A large part, about 8,000, are external identifiers, linking Wikidata to so much other data on the web and off the web, making Wikidata a really excellent hub in the linked open data web and beyond that. And when looking at reuse, just 2 numbers that you might find interesting. Today, we get about 8 million Sparker queries to the Sparker endpoint per day, which is, again, quite a lot. And as you know, we're struggling with those 8 million. But we're working towards solutions for that. More about that later. And about 3/4 of all Wikipedia articles today are using data from Wikidata in some shape or form. Now, outside Wikimedia, our data is used in many, many applications. Here are pictures that I thought over the last year were really cool. At the top, you can see a website called Who Rules, which is looking at boardrooms of very large organizations, companies, and is trying to show you how people are sitting on several of these boards of large companies and how they are basically interrelated and making decisions to the benefit of several of those organizations. A very nice way to bring more transparency into the whole thing. Below that, you can see Interact OA, which is a nice research tool about RNA interactions and graphing them. At the bottom, you can see OpenCheck. When Twitter lost its sensible way of doing verification of popular accounts, this is one of the initiatives trying to provide a more crowdsourced way of verifying accounts on the platform with the help of Wikidata. And last but not least, another highlight is called Notable People, which is in quite a lot of newspapers even, which is a website that shows you this globe, and you can zoom in on various areas of the world, and it will show you the most famous, most popular person, most notable person from that area based on Wikidata, Wikipedia, and more. So what happened on the development side over the last year? One big topic was data quality. We looked at ontology issues, and we talked to reusers. We did a large survey to better understand which types of ontology issues in Wikidata they struggle with the most and which makes it hardest for them to use our data. If you want to hear more about that, and you totally should, come to my talk about it tomorrow. I will dive into the results of that survey. We've also spent quite some time on improving entity schemas, which I consider quite a vital part of improving data quality on Wikidata. If you're like, what the heck are entity schemas? I highly recommend you come to the data modeling days, and we will do an intro on entity schemas and much, much more. It will be in just 1 month. Then we also worked on showing constraint violations to logged out users. So now everyone can see when a statement on Wikidata violates a constraint and hopefully help fix it. We also worked on making some of them easier to understand. So people are not like, I don't know what's going on here. I just know that there's some issue that I don't know how to fix. So hopefully that is improved as well now. Besides that, we've made improvements to the mismatch finder. The mismatch finder is a tool that lets you review differences between Wikidata and some other data stores. For example, right now we have a lot of mismatches between English Wikipedia's local data and Wikidata's data. And you can review, okay, is there an issue with Wikidata's data? Is there an issue with English Wikipedia's data? And fix it accordingly. The mismatch finder now can not just do that, but it can also be used to suggest new statements that so far are missing in Wikidata. And starting next week, it will also be able to work with mismatches on qualifiers, not just the main part of the statement. And last but not least, we have started working towards reducing redundant content, because less redundant content means less content to maintain that would otherwise be prone to data quality issues. Then, in terms of lexicographical data, we have improved things there as well. For example, we have revamped the special new Lexeme page, so the page that you use to create a new Lexeme. That should now be easier to understand, also for people who are not super versed in lexicography. We have also improved the Lexeme page itself. So for example, now it has an identifier section, just like item pages, so you can easily see links to other places where that Lexeme is described as well. And we are working with a team from Indonesia to further improve lexicographical data. And currently, they're working on prototyping a pretty cool micro-contribution tool that I hope we can see in a few months. And if you are excited about contributing to lexicographical data but don't yet quite know where to start, then I recommend checking out the Lexemes challenge, where every week you can help expand Lexemes in a language you speak. Then, in terms of reuse, so people building applications, visualizations, and so on with our data. The big thing was the release of the new Wikibase REST API. Again, come to my talk to learn more. But basically, it's a new and hopefully improved way to access part of our data so that it's easier for people to build applications on top of it. Then we've also started, we have figured out the next steps for scaling the query service, so we can address the issues it currently has. And at the same time, which I think is really cool, Clever and some other Sparkle endpoints are actually shaping up to be useful contenders to Placegraph once we need to move off of it. I'm also very excited about a new part of the team at Wikimedia Deutschland that is focusing on better integration between Wikidata and the other Wikimedia projects. So if you were here earlier in a session about English Wikipedia and Wikidata, this is very much going to help ease some of those issues, because we believe that all the Wikimedia projects should benefit more from Wikidata, of course. And also, in other exciting news, Wikifunctions went live not too long ago. And welcome, new sister to the Wikimedia projects. And I'm very excited to see in the future how Wikifunctions accesses data from Wikidata and what people are going to do with it. And the final point about what happened over the last year is, of course, the Wikibase ecosystem. So this is all about not just Wikidata being a place for open data, but also fostering really a network of many Wikibases that are interconnected and where people share their own data or their institution's data and so on in a linked open data way, and that is highly interlinked with Wikidata. The highlight there was certainly Wikibase Cloud, which went out of private beta. So if you want your own Wikibase and you do not want to install it yourself, then Wikibase Cloud is what you want. You can go there and open up your own Wikibase instance and start working with structured data, just like on Wikidata. And on the Wikibase Suite side, so that is Wikibase, but you have to install it yourself. So for example, institutions might want that because they want to be in charge of their own infrastructure. They're also the team that is working on it made quite some progress and made it easier to run your own Wikibase suite. And the screenshot here you can see are some of the current Wikibases that are hosted on Wikibase Cloud, and it's quite a variety from art to biodiversity and domain names even. So yeah, check it out. Now that was looking back at the last year. So what's coming? What's next? One big topic for me is us being able to handle the scale and popularity that Wikidata has reached. And a big part of that is continuing to focus on data quality. And here, I think it's very important that we, as a development team, build out entity schemas to make them better and more usable. And then, as a community, we make more use of them as a very useful tool for ensuring the quality of our data. And this is one of the outcomes of the ontology issues survey I was talking about earlier. There are a bunch of other outcomes that I think we should also address, again, come to the session tomorrow to see the rest of the outcomes. And in the month, as I said, the data modeling days. And I would love to see many of you there, not just people who are already deeply involved in data modeling, but also if you have a challenge of can't figure out how to model some data, come there and we'll figure it out together. And the other side of this, for me, is continuing to build out the Wikibase ecosystem so that Wikidata doesn't have to be the place where all the open data happens. Then I want to spend quite some time on enabling more people to contribute to Wikidata and to benefit from Wikidata's data. And this starts by making it easier to work with our data as every user, someone who wants to build an application. And we will do this by continuing to build out the Wikibase REST API based on the feedback that people give us, working towards reducing the ontology issues, doing more dedicated outreach to developers, and as I was talking about earlier, improving the integration between Wikidata and the other Wikimedia projects, including Wikifunctions and apps to Wikipedia, of course. On the social side of this, I think I would love for us to bring in more people who are on the fringes of our community and bring them closer to the center. So what I mean by that is people who are making an edit here or there, but who haven't found their place in Wikidata yet, or quite yet. And if that sounds like you, then I highly recommend, for example, checking out Jan and Albin's live editing sessions as a nice low-key way of learning more about how to edit Wikidata, how to work with tools around Wikidata, and much more. It's fun. And question for the people in the chat, if you have a wiki project that people should join and more people should know about, post a link on the chat and see if people join you. And then the third thing that I think is very important for us is ensuring that the technical and social system that Wikidata is relying on, that Wikidata is built on, can support us in the long run. The most important of those is stabilizing the query service. And the next step there is trying to split out a part of the data into a separate place graph instance. Meaning we will test how this will work with scientific articles. You will still be able to query them. You will still be able to edit them in Wikidata, but they will be in two separate place graphs, at least in the test. And then we will see how that is going to work. We will also figure out how to start improving the item UI, because it is a bit dusty by now, let's say. And last but not least, make sure that we get together at events like this, both online and offline. And for some final good vibes, we asked people, what is something that you would like Wikidata's community to know? And people send lovely stuff. So for example, your hard work is greatly appreciated. Keep up the good work. Wikidata builds the foundation of the information society. Thanks to Wikidata, I could do my research. It is indeed one of the most awesome open knowledge graphs. And last but not least, thanks to all of Wikidata's editors. You're all amazing people. And I couldn't agree more. And with that, I hope to see many of you on Wikidata. And if you have questions, please fire away.
Thank you so much for your presentation, Lydia. Always good to start the day looking back and getting excited for the future. I see that we have no questions in the chat so far. So if you're here in the room with us and if you want to speak, please raise your hand and I'll let you know when to open up your mic, or you can still leave a question here in the chat. Otherwise, we can just wrap up the session and prepare for the next one. I see that we already have one question here in the chat by Camilo. So he's saying, could you give more details about your work on reducing redundant content on Wikidata?
Yes. So right now it is very focused on introducing the new language code for multiple languages or multilingual content, with the specific aim of making it less necessary to, for example, add the name of a person in 300 languages written exactly the same way. We're not talking about different writing system and so on, of course, but we have so many cases where we have redundant labels simply because people keep copying the same thing over and over again into different languages. This happens with names. This happens with ASCII characters, many things. And that is the next step. After that, potentially looking at automated descriptions. Still have to figure out how that works together with Wikifunctions. Danny and I have some ideas. On top of all of that, there is a session by Mahir, I believe tomorrow, about potential other ways to reduce redundant content, which I'm very much looking forward to hearing more about.
We have another question here from Chris Bond. So they're saying, whoa, splitting out the scientific article seems like a big step. Is this related to Wixsite or independent?
I mean, anything scientific articles on Wikidata is kind of related to Wikisite. So in that sense, yes. But we have looked at the data, and again, this is a test as a next step because we will have to see how this will work. We will do this on test systems and circulate them with people to give feedback and so on. We're also working with the Scholia people, for example, to figure out how to rewrite some of their queries and so on. But the idea, or we looked at the content on Wikidata, and we looked at the content that is in Placegraph in the triple store. And when you just look at items that are instance of scientific articles and take all the triples that are related to them coming from those items, it is 50% of Wikidata's content, which is a very, very useful split if you have to reduce the amount of data in one Placegraph instance. Anything else is much smaller than scientific articles.
Then we have here Wise Woman asking, how will you deal with scaling to the next 2 years of continued growth?
Yeah, so if this testing with the Placegraph split works out, then that will buy us time. And to, for example, move to another backend away from Placegraph. And one of the good things about buying us time is that right now there are several contenders out there who could potentially be a good choice for us. And they're actively being developed and they're getting better every day. Among them, Clever and MillenniumDB. So if some of you are using those, please do give those organizations, people feedback so they can continue improving their products to the point where it's actually a viable contender for us.
We have another question from Chris Baum. So how far is the work on switching from Blazegraph to Clever? And is that to be expected this year?
Definitely not this year, because this year only has a few weeks left. And this is a huge amount of work, starting with some of the customizations we have in Blazegraph, like the label service that can't just be copied one-on-one, right? We need to find other ways to do this. So that will take time, which is exactly why we're trying to buy us time.
Great. So we have a few comments here on the chat, but I don't see any questions anymore. So I think that it's a good time for us to wrap up. And thank you so much again, Lydia, for this presentation. And yeah, we'll get back here at 3 p.m. UTC in about 10 minutes, I guess, for the session Structured Data and Collaborative Curation, WikiProjects and Wikidata with Daniel Michin. So see you there, and thank you so much.
Thank you.
So we are back at WikidataCon 2023, and now we'll have Daniel Mitchin presenting structured data and collaborative curation, WikiProjects and Wikidata. I'm your facilitator for this session, so by the end of his presentation, I'll go through the chat and you can leave a question there or you can raise your hand to speak up. So Daniel, the floor is yours. Welcome. Please come here to the stage and give your presentation.
Okay, thank you. I'm sharing my screen. Does that work? Can you see that? Can someone give me auditory feedback? I don't see any.
Yes, we can see your screen and we can hear you well. We are all good to go.
Okay, good, thanks. So the purpose of this session here is from my end to basically start a discussion across WikiProjects and across wikis on how we handle structured data about WikiProjects. And I'll start with a brief overview of the structure of the talk. So I will give an overview of what WikiProjects are and how they're named in different corners of the ecosystem. And I'll give some examples of WikiProjects that are actually active on Wikidata. I'll highlight some aspects of structured data that Wikidata has about WikiProjects, give some examples of how WikiProjects use Wikidata, and then basically comment on some of this. But then most of the time I would actually like to spend on discussion on how we can move forward in terms of improving the coordination, consistency of how we deal with WikiProjects. Okay. And you see my entire screen, so any comments in the chat or so I will only be able to perceive afterwards or by media.
Hey everyone, thanks for your patience as we're fixing this technical issue that just happened. Basically, everyone got kicked out, it's not just you. But now we're trying to get our presenter Daniel back. So let's hope we can make it work in the upcoming minutes. Hey, Daniel. I hope you can hear me. I hope everyone can hear me. So, as you may have noticed, we experienced some technical issues and we basically couldn't hear most of you talk. So,
Okay.
a suggestion, since we actually have some extra time because the session was cancelled, and if you don't mind, of course, is that you would start again from scratch and we would delay slightly the next presentation so everyone can enjoy your talk. What do you say?
Yeah, I can do that. I just finished it, and I didn't notice when you were kicked off. I also didn't notice that I was kicked off because, yeah, I shared my entire screen and I was
Yeah, I guess.
expecting that somebody would warn me.
I'm
And
really
I
sorry for
ignored-
that. Yeah.
Yeah, it's fine. I ignored the messages that came in on my phone, but thanks for those who messaged me. Anyway, yeah, I can do also a short or a longer version. The basic thing is I wanted to trigger some discussion, so I had timed it such that I would be finished after 15 minutes, which I actually was. And,
Yeah, which is great, and we can still take some time for this. Really, like let's just admit that nothing happened, and it's still the beginning of your session, and you're gonna take the time that you need for that. So
Okay,
if you want to
okay.
share your slides again and then give the presentation and then have time for discussion, that's great.
Okay, let me do that. So I'm scrolling to the beginning of the presentation. Now I'm sharing my screen again.
Yes, we can see it.
Okay. Do you expect a response, Beat, or how do we handle that? I'm waiting for someone to give me the sign to start.
You can start. Go for it.
Okay. So, yeah, in this session, I want to trigger some discussions about how we can optimize or improve the role of wiki projects in triggering or supporting collaborative curation, and also what the role of Wikidata can be in that, or what it is right now, and how can we improve on that. The talk has a few sections, but it is meant to be short, and so I'll yeah, they are not long sections, so I will give an overview of the wiki projects, how they look like, then which ones are active on Wikidata, and what kind of structured data is available about them, how wiki projects use structured data from Wikidata, and then like what kind of issues are emerging when you deal with these kinds of issues. So first, an overview. Here, there are a number of wiki projects. They come in different sizes, shapes, granularity. Most of our wikis have some. And some of them might already be long going, others might be rather short lived, dedicated to a particular event or so. And they might not also come by the name wiki projects. So for instance, on Wikivoyage, they're named expeditions. And on the German Wikipedia, they are named Redaktionen. Yeah, then which wiki projects are active on Wikidata? There are here is just an example. So Wiki Project Music is caring about music. Wiki Project Every Politician is trying to catalog politicians and what they do. There's Wiki Project Brazilian Laws. There's Wiki Project COVID-19, and there are many others. The traditional way of navigating the wiki project landscape is via categories. And Wikidata has inherited this way of doing it from the other wikis, basically. But yeah, Wikidata does not make much use of categories otherwise, and so also the categorization of the Wiki project is not very intense compared to some of the others. You still can see that, for instance, there are certain types of Wiki projects that are being grouped, those that are pertaining to science or society or sports or geography or things like that. And yeah, so, but Wikidata is about structured data, and so let's see what kind of Wikidata has. What kind of data Wikidata has about Wiki projects. And so there are different kinds of things. The first kind of structured data that Wikidata had initially was just site links, like which entry in one wiki corresponds to an entry in another wiki. Initially, this was meant only for main namespace things like Wikipedia articles or Wikisource pages, basically, or works in Wikisource. But by now it has been applied also to Wiki project pages, and those Wiki projects they exist on Wikipedia. So here, Wiki project Taiwan, for instance, exists on 9 Wikipedias. But there are also some Wiki projects that have presences in other wikis. For instance, here, Wiki project Women in Red has a presence on the English Wikisource and on the Italian Wikibooks. Another kind of information that Wikidata has about Wiki projects is statements. I've chosen here a simplified representation of some statements about Wiki project COVID-19. So it's an instance of a Wiki project. It's also tagged as an instance of a biological database and a medical database. That is to some extent debatable. It's expressed that this Wiki project is interested in the virus SARS-CoV-2, the disease that it causes, and the pandemic that came from it. And it has a main category like this. Most Wiki projects do not have much more in terms of annotation, although some actually go into more detail, like when it was founded and things like that. But there is room for further annotations. Once we have structured data, we can kind of run queries on it. And one way to do that is via Scholia, which has a dedicated Wiki project aspect that you can use to browse what's known about Wiki projects in Wikidata. And yeah, from that we see that, for instance, the scope of different Wiki projects is quite large. So, for instance, here the document the Project Riksdagen from the Swedish community about basically legislative documents and also politicians related to their national parliament has 250,000 items in their scope. A similar order of magnitude also for Wiki project Invasion Biology, so a science project, and New Zealand thesis project, another one with a national scope. So yeah, Scholia also has, let's say, profiles for individual properties, and so I pulled out the two that are most relevant for Wiki projects. One of them is called On Focus List of Wikimedia Project, P5008, and the other one is called Maintained by Wiki Project, P6104. And we already see that both of these properties are used quite intensively, but essentially there is very little overlap. Most projects use just one of them. There are some that use both of these properties, but there is not a lot of consistency actually. But structured data can again help surface these things, and then we can have a discussion about how things could be improved. Then some of the ways in which Wiki projects use Wikidata is essentially to fill gaps. So here we have Wiki project Women in Red, which is concerned with missing articles about women on wikis in general. This example is from the English Wikipedia. And so even though the English Wikipedia does not have entries about these people here, there is some information from Wikidata that's being harnessed. There's also information about site links. So if two wikis already have information about that person, then maybe we can check out that information, and that helps in writing the article in English. Yeah, and the use of Wikidata across wikis and also within and across WikiProjects is quite diverse. But I would say WikiProject Women in Red is one of the more elaborate uses, and so it can serve as an interesting example, because lots of facets of how you could be using Wikidata data are actually popping up in that context. Another aspect here, you can what's interesting about this is you can actually structure the gaps in your own wiki by additional knowledge. So if you would say, without knowledge external to the English Wikipedia, it would be hard to say which of the red links are actually microbiologists, for instance. But thanks to the additional information that is available via Wikidata, you can actually structure the gaps that exist inside a given wiki. Now some observations. So we have a number of workflows to, let's say, help with consistency within WikiProjects. These are things like listeria and integrality. These are tools that basically look at how things are or how things could be, should be. We also have constraint violations. They typically are not tagged as being for a particular wiki project, but in practice there is quite some overlap. In terms of consistency across wiki projects, I already mentioned the P5008 and P6104 kind of thing. There is just little consistency. And then another example where wiki projects are not consistent is the granularity of the instance of or subclass of values. So for instance, for anything that is a human, we say that it's a Q instance of a human, Q5, and then all the other specifics you might want to express about that human, they're expressed using other properties. Whereas for other things, like for instance, publications or many other things, we put the granularity directly in the instance of statement, which then is an inconsistency that for wiki projects that cover multiple types of things causes problems. And for discussions around that, the mechanisms are actually different on Wikidata as compared to many of the other wikis, because on Wikidata, the talk pages for individual items or so are essentially not used, or much less than on other projects. And so, that changes the nature of the discussions. Also, it's a multilingual site, which also has an impact on how the discussions go. And so that's why I'm putting here decision-making as yet another thing that might be worth discussing. And that's basically the kinds of things I wanted to discuss. The slides will be available under this DOI. I haven't uploaded them yet. Now I'll go back to, I'll stop screen sharing for a moment so I can see the chat. Okay, somebody thanked me, so I suppose you heard me.
Yes, we did. Thank you.
Okay, yeah. Now it's basically up to everybody else to say something. I have no time. How much time we now have?
We still have plenty of time. So if people want to say something, you can either raise your hand and then you will be granted the right to speak, or you can also write in the chat. I see that we have Lydia.
Yeah. Yes. Thanks so much, Daniel. That was super interesting. One thing that I was missing from your observation, and that I would think would be super useful if we all spent some time on it, is that a lot of the wiki projects aren't very explanatory what it's about, right? If you are new to Wikidata and you get thrown into a wiki project, it's very nichey and clicky and not super welcoming. And I think it would be super amazing if we could all spend some time on making that a bit more welcoming and easier to understand what each wiki project is about.
Yeah, and for that, it would actually help to have a more general introduction as to what a wiki project in general is about. And also, sometimes we have these distinctions between a wiki project and we have the task forces. For someone who comes new into the ecosystem, there's also a distinction between the wiki projects and the Wikimedia projects. And then any individual projects within any of that. So yeah, it's complex, complicated. And yeah, that's the kind of thing that I think would merit some more discussion, which is why I wanted to have this session.
We have one question here in the chat from Peter. So he's saying one problem is how to infer what project is interested in an item. For example, WikiProject ships is linked to from ship, but how can one figure out that stream ship or Titanic is part of the project?
Yeah, you could go in and tag those things with one of those two properties, or maybe even some others. And typically, this is being decided within a particular wiki project. So somewhere on the main page or on some of its sub pages, there will usually be some guidelines on what to tag and how. But yeah, as is often the case, the documentation is not most complete. It might not be up to date. It might not actually accurately reflect actual practice. And even if it did at some point, then somebody who's new and joins the project, they may not follow that entirely, or they might actually follow the documentation, which is basically reflecting outdated practices. And so the inconsistency can come in multiple ways.
Thank you. I see that we have one hand raised here. So Bit, please open up your mic and speak up.
You have to allow me, I think.
No, we hear you already.
Okay, everybody hears me? You need to broadcast me, I think. Oh, okay, perfect.
Yes.
Okay, thanks a lot, Daniel, for this presentation. A major challenge I'm currently observing is that the class structure, subclasses, the class trees, they're shifting around a lot. And it's very hard to keep them tidy. And they are something that is often shared between Wikidata projects. So do you have any ideas or thoughts on how we can come to grips with that?
Ideas, yes. So, for instance, if you go to the Scholia profile of an individual wiki project, you will see there is a panel on basically neighboring wiki projects or other wiki projects that are tagging the same things or overlap with other wiki projects. And the reason why we included that is to basically facilitate discussions. If wiki project ships notices that they have overlap with wiki project trees or whatever, I'm just making this up, then they could have a conversation about how to model the materials that the ships are made from, or something like this, right? Right now, this does happen because most people who are active in one wiki project, they're also active in some other project. And so they transfer some of the habits from one to the other. But it rarely happens at a systemic level so that a wiki project as such is having a conversation with another wiki project as such at the wiki project level. And that's the kind of thing for which I think we need some better channels.
We have a question here in the chat from Frederick. So he's saying, what's the conceptual nuance between the two properties?
Yeah, I'm not entirely sure I'm the best person to report on this. But as far as I understand, and I actually tried to summarize it on the discussion page of both of those properties, there is the concept of a focus list, which means that there is a list that is explicit, and so everything that's on the list is considered the focus list, and then there is a dedicated property to express the fact that this particular item is, or even property is on the focus list. And each wiki project can decide what goes onto the focus list. And that's what the P5008 is for. It has traditionally not been used that way. It is often used by projects that actually don't run an unfocused list. And I think that was one of the reasons why the other thing was proposed, but I didn't really dig into all the history of that. And the other one basically just says maintained by WikiProject. And I think it was originally intended for just properties. It is by now being used for items as well. And so that's yet another inconsistency. Should we use the tagging, the same kind of tagging for items and for properties, and maybe even Lexemes? I haven't actually looked much at how the Lexemes are being tagged. But for the moment, yeah, these are the two main properties, and they're used in rather inconsistent ways, but somewhat consistently inside most of the wiki projects.
And we have a few comments here in the chat, so I'll go through some of them. And please, Daniel, feel free to build on them. So RTNF is saying, what I like about wiki projects is that they provide a sense of legitimacy regarding which items are considered notable enough to exist on Wikidata. For example, when we experimentally add a new kind of data to Wikidata, something that has hardly been modeled before, this type of experimental item is subject to high scrutiny by the community, and there is a significant chance of deletion.
Okay, I don't know where you saw this, but this sounds very relevant. Yeah, can't say much more.
Okay, then Peter is saying a big problem with projects in Wikidata is that either there are few people interested or there are too many people to use the project tag to communicate.
Yeah, that is this limit. We have one mechanism by which you can basically ping people, and this ping mechanism typically stops at 50 like addressees. And also, even if you are being pinged via this mechanism, it's typically not clear like where precisely and how precisely you're being pinged, because it is treated as if you were pinged personally, but you weren't. And yeah, so there's room for improvement of those communication channels.
Yeah, another comment here is that maybe these projects need more structured approach, like having templates for item models, entity schemas, tool workflows, etc. The availability of this is very hit or miss between projects, or sometimes even conflicting. Do you have a comment on that, Daniel? Anything that you want to add on this?
Yeah. So these kind of problems that I outlined here, they're not entirely new. They have essentially been experienced by most of the other wikis as well. And in most wikis, there have been occasional discussions about it, but nothing systemic has been done about it. On the English Wikipedia, in contrast, there has been a project called WikiProject X almost a decade ago, I would say, not entirely 10 years. Which actually tries to come up with templates, tries to make it simpler to set up a wiki project, tries to make it simpler to onboard people, tries to make it simpler to come up with policies and all the things that you need in order to start a wiki project. And this, I think, to the extent that I remember, it had a useful set of pilots, but I think it was never really rolled out at scale. And yeah, I don't think anyone has actually even planned of doing something similar on Wikidata, but I think Wikidata should actually be even more amenable to this kind of standardization. But yeah, might well be, yeah, somebody asked, is there a wiki project? There might well be, but like most wiki projects are actually essentially dead. And so even if there is a wiki project, it doesn't actually mean that it does what you would expect it to do. That is yet another problem. But on Wikidata, it should also be easier to detect these kinds of things. And especially if the items are tagged properly. But yeah, it's kind of a chicken and egg problem. If it's not properly tagged, we can't really detect too much what activity is going on within the scope. If the scope is not expressed clearly in structured terms, it's hard to say. Then also the question is, if we suppose we could express the scope of a wiki project in structured terms, let's say all instances of Q5 are within scope of wiki project biography or something like this. Then the question is, should we still tag the individual items that meet this criterion? I could see arguments for in both directions. One, like for this kind of tagging, would be that it makes the querying easier, and it also makes it easier to co-discover, like let's say, other wiki projects that do the same thing. But yeah, as Nicolas is pointing out, this would be redundant in many cases, and so yeah, it's yet another kind of thing that would would need discussion and certain weighing of considerations, some sort of systemic optimization.
Thank you, Daniel. And I'll jump to a very on-point question here from Tuka. So they're saying, are there plots about a project's activity over time?
I think I've seen something like this, but it was piecemeal, probably for just single wiki projects, or maybe 2 or 3, a handful that just happened to have the same people involved. And I know WikiProject Medicine on the English Wikipedia has been rather systematic about this for a while. I actually don't know what the current state is. So they typically ran a bot every year, I think, once a year, that kind of summarized how many people were doing something within the scope of that wiki project. I haven't seen anything similar on Wikidata.
Thank you again, Daniel. And Peter, is your hand raised, or do you want to open up your mic? Please feel free to be here on the stage with us.
I don't hear Peter. So while there's silence here, I would like to comment on this. Oh, okay, go ahead. Peter, please go ahead. Well, to me, it sounded as if someone wanted to say something. So maybe it's just the echo that I'm getting while I'm speaking. And so I'll comment on the inference issue. So in theory, it's enough if we tag things just once in the graph, and then we can infer these things by just queries. The problem is if you deal with larger graphs, like all people or all stars or all wiki site items, then we're reaching the limits of the query endpoint, which is the reason why certain things are tagged actually in a redundant fashion. So we have things like inverse properties, which in most cases wouldn't actually be necessary if inference would work properly. And also we have things like essentially every geographic item is being tagged as what the country is it belongs to. So even though it might already have other geographic information that essentially also maps to the country. And so there are several layers of redundancies in the graph already, which have various pros and cons. And the tagging for the wiki projects would basically fall into the same category. But I think it would be useful to have that discussion on the scale of Wikidata rather than on a per wiki project basis. And yeah, I would also think having, let's say, a standard for setting up wiki projects would be useful, and some technical support that would at least be aware of that standard or help enforce it would be nice.
Before we move on, Peter, can you please try to raise your hand again and try to speak? Because I feel like you're trying to talk, but yeah. Let's see if you can talk now. Can you open up your mic, please? Talk. Yeah, we still can't hear you. Please feel free to write a question in the chat. We still have a few minutes here. If anyone else wants to raise your hand and speak, and this is your time as well.
Well, while we have a moment of silence, I would encourage everyone to just go to a random wiki project on Wikidata or even elsewhere in the ecosystem. Think about how this system could be improved. To what extent could particularly structured data about the wiki projects help? So for instance, should we have a dedicated property that defines the scope in a way that's different from main subject or similar things that we already have? Should we have entity schemas, and should we build tooling that actually, or should we have constraint violations that are specific to wiki projects, things like that? Or should we set up a template, a dummy, a sandbox, or a forkable Wikidata project, or some wiki? What? I'm tired. A forkable wiki project, something like this, right? So please just, whenever you come across the next item or the next wiki project, just think about this and then share your thoughts.
Daniel, we have Peter here. So he's saying another problem is that Wikidata provides little support for the modeling needed in many projects. For example, there are meta classes in ships, but there is nothing that prevents, for example, a ship like the Titanic being a subclass of a steamship.
Yeah, modeling support is not trivial. I personally use a lot of those Wikibase, throwaway Wikibase instances actually from Wikibase Cloud for this kind of thing. It's if you're not sure about the data model, it is a bit problematic that on Wikidata you first need to create the property, and most people can't do that. And even people who have the right, like the technical right, they don't have the social right to create properties. And all of this is good for good reason. And not everyone wants to set up their own Wikibase, and so yeah, it's complicated. And modeling support, I think, the upcoming data modeling days, they already kind of have sensed this as a problem, and I personally think we should have more of those. We should have regular modeling sessions, and the question then is to what extent we can make this a Wikidata-wide activity, because the modeling typically is very specific. It is like to go back to some that I was involved in personally, is whether on an item about a scholarly article, the issue should be a qualifier to the volume statement or to the journal statement or not. Right now it's a flat structure, but there have been suggestions to make it a qualifier, right? Things like that. That's very specific, and most people, even on Wikidata, would have very little interest in that particular discussion. But data modeling, as in general, is probably of interest to most people who participate in Wikidata. And so we have to find a way in which we can balance this needed specificity to get the models right with the, let's say, community habit of actually making modeling part of the routine things and building workflows, tools for that. We already have pages like request a query, and maybe we should have something similar that is called request a model or a data model or something like this. And then let's see how things develop. This request a query is a fascinating page. It's one of the highlights of the Wikidata culture, I would say. And yeah, there is a request page for entity schemas, but I don't think that's necessarily the same thing. So A data model can be thought of in terms of entity schemas, but that's a rather formalized model already. And I think initially it's just enough, okay, we want to have a few statements and they should involve these properties. It's essentially the same thing what the entity schema says, but most people prefer to read some human readable text rather than an entity schema. And we don't have an automated conversion to and from either. Maybe the GPT tools can help with that.
And Beat has one comment here. I wonder whether it would be useful to protect central class items. It is particularly annoying if the top-level ontological structure of your field keeps changing around. Do you have an opinion about it, Daniel?
I understand the sentiment. I'm not particularly sure about which particular top-level structure you're talking about, Beat. I have seen a few flips. I don't see the same flip happening often. Most of the flips that I see, they are actually in different parts of the ecosystem, sometimes quite related, but not like an edit war going on or so. But yeah, vandalism to class items is a different beast than a vandalism to a description in a particular instance of a class. And so, yeah, we should probably think about layers of protection in a more hierarchical or more ontological way.
So great. Thank you so much for your presentation, Daniel. Thank you, everyone who commented here on the chat. I think we can have this quick 5-minute break until our next session. That will be Supercharging Wikidata with external aliases and new entity types. Thank you so much. And yeah, let's keep here the energy going for this day of WikidataCon. Thank you so much.
Thanks, everyone.
Okay. I think it's time for the next session. Let's check if the presenters are on. Not yet.
But we do have the pre-recorded video, so we could already start with the presentation and see if Jan joins.
Oh, this is a
later.
pre-recorded. Oh, sorry. Yeah. Okay. Sorry. Welcome, everyone. I hope you enjoy your break. So my name is Mohammed, and I'm here with my colleague Alan. We are going to be facilitating.
Yes. Hi, Mohammed. Hi, everyone.
So we are going to be your facilitators for the next 30 minutes. I just realized the session is pre-recorded. So we are not going to have Johan and Jans here, I think. That means we are going to play the recording, and if there are any questions or comments you have for them, put them in the chats, and we can forward them to Johan and Jan and hopefully get some feedback from them. So yeah, we are ready. If the video can be broadcast now, that would be awesome. All right, so
hello everyone. Let me start by introducing myself. My name is Jan Almiras, and I'm a solution architect at Orange Innovation in Lannion, a small city in Brittany in the west of France. I've been working for a few years now on Wikipedia data, and more specifically on Wikidata as part of several internal projects. The small name of this project, R2D2, is linked to its use through APIs and a nod to the world of Star Wars. Now I'm going to show you what this project is all about through this presentation, Supercharging Wikidata with external aliases and new entity type. The goal of this project is to create a lightweight database from Wikidata, enriched with new aliases and improved entity typing. The first goal is to increase the number of aliases of each item to improve item identification. The second one is to create a new property for object. The idea is to create a generic main type property for type recognition. The third purpose is to create new relations between objects to be used in enterprise knowledge graph. And at the end, I will show you the use of Kibana to help data exploration, error detection, and to find ways to improve database integrity. Before continuing, I'm going to describe the first use of R2D2 database. The first objective was to retrieve information from the Wikidata hyperlinks. I also needed to retrieve the redirect links in order to have all the information. For internal purpose, colleagues have asked me to generate specific lexicons for the needs. Someone worked on the recognition and other on named entity detection. This project has also been used to identify items for several projects. The main use is the detection of named entities. In this case, the answers are often ambiguous because the type may be different. The ambiguity is even more difficult to resolve when they are subjects of the same type. For example, there are several cities with the label Paris. Now let's look at the back office of data collection. The first stage uses a set of files to prepare the data for indexing. I will detail the entries later. The second stage feeds the index specific for each language according to the filtering criteria described in the configuration file. The input data is obviously the Wikidata dumps for generating language-specific indexes. A set of filters are applied to rank only the most representative data. I used Wikipedia SQL dump for certain types of calculations such as PageRank. I also use mapping data to integrate the Wikipedia taxonomy. Finally, I added Wikipedia summaries from Wikipedia Hub. The output data, that which is indexed, refers to the main description data. Other data is added depending on the project. There is an index by language. For the moment, there is an index for French and another for English, but it's easy to extend the system to other language. The principal informations are Wikipedia ID, the label, description, instance of, type, Wikipedia URI with redirection and page rank. And I add other information for project's purpose, like geolocalization, date begin and end, population, occupation, imagining, and so on. Now I'm going to present you the use of R2D2 API. For that, I'm going to make a search request on Wikidata ID. I choose English index and the Wikidata ID Q42. In response, I got the item Douglas Adam with several information, label, image, date of birth, date of death, the sum of alias URI, all the alias text. There are alias that come from Wikidata, redirection, and other information like pseudonym. We got to the main type, R2D2 human, Wikipedia person, and other information like subtypes which correspond to occupation. And we got the summary, the path Wikipedia, and the page rank. Now I'm going to present you how to retrieve label or aliases with R2D2 API. To get a label, I chose London and English index. I put the size to 10. I decide to change the size to 100. And here we can see we got 43 hits for London. There are different types of London cities in Canada, a record label, and so on. In the second time, I'm going to show you how to get alias and retrieve item with the alias. I choose Ville Lumière, the English index. There is no response because it's not exactly good orthograph. And thanks to the alias database, we retrieve the good answer, which is Paris. One of the main features of R2D2 is the addition of new aliases to improve the detection of named entities and other items. For the moment, the two main sources are Wikidata dumps and the dump of redirect page from Wikipedia. In Wikidata dump, we retrieve all Wikidata aliases for each item, and we add other aliases who come from specific properties like official name, native label, nickname, and so on. With Wikipedia redirection dump, I use a redirection, in this example Panam redirect to Paris, to store new alias, in this case Panam. To illustrate alias indexing, I perform a search request via the API with Karl Marx. The result shows all the aliases selected. For Karl Marx, there are 19 aliases. Another index details the source of the alias, Wikidata, redirection, or property. Here is a pseudonym. In this slide, you can also see some of the other information stored in the index. Now I'm going to talk about the main type. There are useful properties for identifying what an element is, but this property could have several values in Wikidata. So I decide to create a R2D2 specific property, the main type. There are two main types in R2D2, The first one is a homemade main type. It's a manual selection from a graph database or UNDB where only some properties are stored. Instance of, subclass of, a part of. Actually, 19 main tab was defined. Each main tab is an aggregation of Wikidata ID. For example, the main tab city is an aggregation on 291 Wikidata ID. But there are no other main types like a conflict, works, and several points of interest such as castle, museum, restaurant, tourist attraction, and so on. The other main tab is the Wikipedia main type. I keep in the index the full path of Wikipedia taxonomy, and I select just the most relevant information in the past. For city, the most important is city. I'm going to present you some examples of usages of R2D2 database. The most current use is the data identification to retrieve items information with a label or an alias. The second one is the data association. The summary API is used with a multi-match search to discover new links between items or to retrieve items using multiple keywords. Data visualization with Kibana allows improvement of the main type, identification of error on date, geolocalization, and so on, identification of differences between Wikipedia info box and Wikidata information, taking a step back on the representativeness of data, cultural and temporal aspects, identify interesting data for new services. In this example, I'm using R2D2 API to retrieve one or more items associated with two keywords. The first keyword is the naming entity, Les Misérables. The second one is the date. The search engine will search the database for all items that have these two keywords in the summary. For these two words, there is only one entry, Victor Hugo, a famous French author born in 1802. Now I'm going to show you just the usage of Kibana for R2D2 database. I've chosen the English index. Here I selection the number of values that I want. Up. And these are the labels that are the more represented in R2D2 English index. The Washington townships have particularly 200 records with this label. Then I add a filter to get only the main tips value person. In this example, we see that John Smith is a more represented label for English, and John Browns has 41 label called John Browns. In Kibana, I can change the index. Here I take a French index. I just modify the filter because it don't have exactly the same value. And we find only 9 records for John Smith in a French database. On this Kibana dashboard, we can see the distribution of items by main types. The number of items seems small, but as a reminder, only items with the associated Wikipedia record are taken into account, and a set of items is filtered, such as homonym pages. As we can see, there are almost 3,500,000 items for English index and 2,300,000 items for French index. There are 4 possibilities: items with either one or the other main type, those with one of each and those without. Approximately half of the items are for R2D2 main type. These types are distributed in 19 categories manually defined. Approximately half of the items have a DBpedia main type. This Kibana dashboard shows the difference in population distribution between India and China. Both countries currently have over 1 billion inhabitants. I made 2 queries on the English index. The first takes into account all items with a population greater than 1 million inhabitants, red point of interest. The second one also takes into account the city main types, green point of interest. In conclusion, populated areas with more than 1 million inhabitants are concentrated in China's major eastern cities, while in India they are more evenly distributed across the districts. On this Kibana dashboard, I wanted to display the element seat of special scientific interest. I found that practically all the points of interest were located in England. This information only comes from the DBpedia mapping, which must have been used to type the corresponding item. Now this information is stored in property P1435 heritage designation. This Kibana board illustrates the differences between Wikipedia Infobox and Wikidata properties. I made 2 queries on the English index. The first one takes into account all items with conflict R2D2 main type without dates in Wikidata, being point of interest. The second one takes into account all items with conflict R2D2 main type, but with a date specified in Wikidata, yellow point of interest. Then I searched Wikipedia for a conflict that didn't have a date. I choose Lanyon because I live here. It's in French because there is no Wikipedia input for this item in English index. On Wikipedia, the date of the conflict is present. There are several difficulties with retrieving information from Infobox. Some Infobox information can be different according to the language. Sometimes the population indicated may vary because the indicated number is for different dates. Wikidata is a rich source of information with both good and bad sides. Some properties are more important than others in typing domain, in sense of versus subclass of. There are often mix-ups between the two and confusion between semantics. For example, horse can be a taxon and a vernacular noun is not the same semantic consideration. I put some entries to granular. Several items corresponding to the title of each chapter of a book. It's like trying to store all natural integers in Wikidata. There are differences between Wikipedia Infobox and Wikidata information. It depends on the language and the date. These encyclopedias are alive, evolving with times. I've observed a lot of Wikipedia and Wikidata entries generated by bots, especially since 2013. Wikipedia and Wikidata are bound to come under the influence of large language models in the years to come. That said, there are some interesting prospects. Certain topics remain to be developed. Where does the data come from? Bot or man? Both? How can we verify the veracity of the data? How to study the history of the data? Future work on R2D2 will focus on 3 areas. Create a bot to enrich a Wikibase database from R2D2 for an internal project, Enterprise Knowledge Graph. Implement and propose bot for Wikidata. The second objective is to improve ontology to correct R2D2 main types, to add new ones, to add new sources to enable better classification. The final short-term objective is to use the summary API to generate new relationships specific to the telecom business domain. My presentation is finished. Thank you for your attention. I would like to thank Pascal Belec for helping me generate the main type R2D2, Johan Chabot and Frédéric Erledon for their advice, Halagang for inviting me to take part in this conference. Thank you.
Thank you so much. I'm just wondering, is Johan here? I don't think Johan is here with us, but that is fine. So looking at the charts, I don't see any questions though. Okay. If you do have any questions, even later on, you can put it in the chat and we would forward it to Johan to take a look and respond. So thank you everyone for attending. We are going to go on a 2-hour long break. So it's time to, go for lunch, dinner, whatever you like doing. Just take some fresh air if you like. And we will come back at 8:30 Berlin time for our next session around the Wikibase REST API. But in the meantime, for those of you who prefer to relax by playing games, Lydia is going to be running a game in the game room. And your first task is to figure out where the game room is. So good luck to all of you. I don't know if there's a prize for people who get to the game room first, but maybe there is. All right, thank you everyone. We would go on our long-awaited break now if people don't have questions to ask. All right, bye.
Thank you, everyone. See you later. Bye. Hello, everyone. Just a gentle reminder that the next session will start in approximately 10 minutes time. So please feel free to grab a coffee, grab a drink, and see you all here in 10 minutes time. Hi everyone, welcome back again. I hope everyone has been well rested over the past 2 hours or so. Our next session is going to be on the topic spreading our data further with the Wikibase REST API by Lydia Pincher. My name is Alan Ang from Wikimedia Germany. I will be your facilitator for this session. So as usual, if you have any questions after Lydia's presentation, feel free to raise your hands or write them down in the chat, and I will read them out later. So I think we are on time. Let's give the floor to Lydia. Lydia.
Thank you very much, Alan. Yes, one of the very exciting things that's been happening around Wikidata, as I mentioned earlier today, is the new REST API for Wikibase. And I want to give you a bit of background on that. So the first question is, of course, why do we need a new API for Wikibase? And basically, we really want Wikidata's data to be used to build amazing applications, be it funny ones, be it educational ones, be it quirky ones, niche ones. More people should be using our data to build applications, right? And I think that's what we all want. And the same is true for other Wikibase instances, of course, not just Wikidata. Now, the problem is that for many reasons, this is hard. And one of the reasons this is hard is that people are having problems with our Action API. So that is why we are building the new Wikibase REST API and have released it in a first new version. So with this new REST API, we want to provide an API that's a bit more industry standard and versioned, so people can access and manipulate data in Wikibase who in ways that might be more familiar with them if they are used to other APIs outside of MediaWiki. We also wanted to provide an API that is a bit more tailored to the Wikibase data model, so it should know about things like items exist and properties, and they have statements and they have labels and things like that, which the Action API kind of does, but it was a bit shoehorned into the API that was built for Wikipedia's text initially. And besides that, we wanted to solve a few bugs and other issues in the Action API that are just easier for us to fix in a new REST API. And ta-da! Here's the current state of the new REST API that you can already work with. It's live on Wikidata. And once I put the slides on Commons, you can also look at the documentation and everything and see all the different API endpoints that you will have access to. Now, with this new API, what can you do already today? You can get the data for a single item or property. You can get their labels, their descriptions, their aliases, either in all the languages that are available or just one particular one. You can get the data for particular statements or all the statements of an item or property. You can modify the data within a single statement on an item or property. And you can modify the labels and descriptions that are on an item and property. So it's already pretty powerful. Now, if you are familiar with the REST API, there are a few things that are a bit different. Let me dive into them. The first thing that might be new to you is in the Action API, which is on the left here. We talk about claims. In the new REST API, we talk about statements, which is a bit more familiar to people. Then overall, again, on the left side, the Action API, if you're getting the data for a particular entity, like Q11, then this is a fairly deeply nested structure. And if you do the same for the REST API, you can see that it's a bit more flat and a bit more readable, arguably. Then if you look at the individual statement data, in the Action API, you would have, for example, a main snake field that you no longer have in the REST API. The same for the main snack hash and data type, data values type. And there is a new property top level field and a new value field added that contains the ID and data type for the property and the content and the type for the value. And in those responses, you always get all the fields returned, even if some of them are empty, to make it more consistent. Now, if you look at the metadata you get back when doing these requests, we no longer return the page ID and the namespace and the title field. We have moved the revision ID and the date it was last modified to the HTTP response instead, so you no longer get it in this response. And the same for the success state, like has your request succeeded, is no longer in the data itself, but instead in the HTTP response code. Again, making it a bit more what people are used to. Then let's look at editing. When you're trying to set a label, for example, or a description, then in the Action API, it would work like at the top here in this URL. And in the REST API, you use the labels endpoint or labels in the items endpoint, and then you submit the label you want to set and potentially a comment, so the edit summary. And then in the response, you get your new label that was set. And then if you are creating a new statement, it works similarly. In the new API, you submit your statement with the ID for the property that you want, as well as the value and value type that you want to submit. And then you get your whole new statement returned to indicate that your request was successful. Then, and this is not possible this way with the Action API, but with this new and very powerful in the new REST API, is patching. So here, what you can see is we are trying to patch an item, and we're trying to patch its labels. So, for example, we are submitting here a request to remove the Swiss-German label and to add a new British English label, and to replace American English label. And then we get back, again, the new labels in those languages that we set. Now that, that you've seen all that, you might also notice that, of course, this is not a complete API. Not all the operations you might imagine to do on Wikidata you can already do with it. It's a first step towards that, while already still powerful. So what is next on the on the horizon? The ability to modify aliases of both items and properties, getting and modifying site link data on an item, improving some of the error responses that the API returns right now, as well as properly versioning this API. And with that, you got a very quick walkthrough through the new REST API, and I hope that some of you will try it and build something cool with it. If you do, please let me know. And if you have any feedback to help improve this new API, please do leave us feedback here on Wikidata at Wikidata:/REST API. We would really appreciate it. And I'm happy to take any questions you might have.
Thank you, Lydia. So let's open up the questions to the floor. While people are thinking about questions, we have one question in the chat by Nicholas. Question is, could claims be a valid alias for statements for us, the older Wikidatations?
Sorry, can you repeat that?
Could claims be a valid alias for statements?
If you look at the data model, there is a philosophical difference between them. So, for example, one of the differences is references. So, to make it simple, a claim with a reference can make a statement. Yeah.
Thank you. We have another question by Simon. What authentication method is used?
Yes, you can go to Wikidata:/REST API. There, among other things, we explain how to authenticate with the API, but it's basically auth.
Yep, you have received many thank yous from both questions. And Nikki has a question. I just read from Nikki's question. My main question is, why did you change data type without a hyphen, one word, to data-type? That makes it more awkward to use in JavaScript. So that's the first question.
You're not the first one to say this, and I will take it back again to the people who have been working on it mostly. Yeah, yes, granted.
Okay, thank you. Chris Baum also asked a question. Is editing Lexemes possible yet?
So far, no, because we need a new endpoint for editing Lexemes, but that is pretty high on my wish list, of course, as you can imagine. But so the things I mentioned here have to happen before that can even get started. And also, we would like to see some more feedback on the current endpoints for properties and items, so we get a better feeling of how people like it, if there are weird things like Nikki mentioned that we should improve before we add support for more entity types like Lexemes.
Okay, great. We have a question from John. John asked, does Wikibase REST API support all namespaces, including Lexemes and entity schemas?
That's basically the same question.
Yes.
Same answer.
In the wish list. Okay, I do not see any more questions coming in. Maybe we just give about 10 more seconds for some people if you have any question. Yes, there's another question from Chris Baum, who asked, is the REST API easier to handle for Wikimedia servers than the Action API?
I'm not sure, but it should make that much of a difference. So, for example, one of the reasons we have the REST API is to make it easier for people to switch to it who are currently using the query service for something that doesn't actually need the whole graph. So if you just want one statement on one item, you don't need the query service. It's way too big a tool, right? And it's we would like people to do that in the future via the REST API, preferably, because it is less burdensome on the service than doing that via the query service.
Thank you, Lydia. Any more questions from our participants in the room?
If not, I would like to reiterate my request. Please try it out. Give us feedback, and if you have built something, even if it's just a little demo app, I would love to hear about it.
Okay, there's one question that just came in, Lydia, by John. The question is, will the current Media Wiki API be eventually deprecated in the upcoming years?
Yeah, so definitely not soon, but it is indeed not viable long term to maintain both of these APIs for us, right? We very strongly believe that this is a more future-proof API, but if and when it comes to that, we will have announcements and long migration periods and so on, because we know that a ton of things depend on the existing API. So that's not happening anytime soon.
Okay, thank you, Lydia. There's another question by Nicholas. Is there a central page for later question? I think meaning to say that is there a place or a page where
Yes.
the community can post questions regarding REST API?
Yes. So definitely on WikidataCon REST API, the talk page there is monitored, but also happy to take some questions on Telegram, for example, but ideally on the talk page of WikidataCon REST API.
That's great. Any further questions from our lovely people here? No? If not, then maybe I have one little question for Lydia. Lydia, yes, you mentioned earlier on that you hope that the community will be able to, test it out and, provide feedback later on. But is there any way where the community can also, the members who are here can also, spread the word and also share with other members of the community that, this is
Absolutely. Shout it from the rooftops. Tell people who in the past maybe have talked to you about building something cool with Wikidata, and then we're like, oh my god. Maybe share it with them, and maybe this is easier for them to grasp and use.
Yes, that's great. Yes. Okay, I think there's no further questions from the audience in this room. Then in that case, thank you, Lydia, for the presentation and sharing Wikibase REST API. And thank you, everyone, for your participation and your questions as well. Thank you.
Thanks, everyone.
I'd just like to share that the next session will take place in about less than... Okay, I just check in case I've missed any last minute question. The next session will take place in about 20 minutes time. So we have a short break until then. And the session topic will be, let me just check to make sure I'm correct, semi-automatic tagging of images on Wikimedia Commons. So I look forward to see everyone later. See you. Hello, everyone. Just a gentle reminder that our next session, semi-automatic tagging of images on Wikimedia Commons, will start in 5 minutes' time. See you in a short while. Hi everyone, welcome back. For this upcoming session, we have Beat Esteman, who's going to talk to us about the semi-automatic tagging of images on Wikimedia Commons. Without much further ado, let me hand the mic over to Beat. Beat, the floor is yours.
Okay, thank you very much, Alan. I hope everybody can hear me and see my slides.
Yes, we can hear you and see your
Okay, perfect. Welcome back, everyone. Today I will tell you a few things about software development project we carried out over the past year. It's about semi-automatic tagging of images on Wikimedia Commons, and maybe I should have chosen the title towards semi-automatic tagging of images on Wikimedia Commons. But let's jump into the story and leave that other part for the end to keep up the tension. So what was the background for this project? The original idea or intuition was to leverage the power of artificial intelligence for the tagging of images on Commons. And I kind of carried out or mandated a couple of student projects at the Bern University of Applied Sciences back in 2020 and 2021. With the idea of leveraging deep learning approaches for the tagging of images. Then we also quite rapidly arrived at the idea that we should not just use the tags that they would provide out of the box, but link the concepts to Wikidata. Then the idea came up to actually develop custom models to escape the black box approach of proprietary algorithms. And we also, during the first tests, combining different of these algorithms, we understood that the way forward is not fully automatic tagging, but semi-automatic tagging with a human in the loop, because automatic tagging will never be precise enough for the current needs of Wikimedia Commons and other applications. We then found out that there were actually two tools existing on Wikimedia Commons that we could just combine for a start, and we ran a pilot project on that. So one of them is the computer aided tagging tool that uses Google Cloud Vision and has been implemented on Wikimedia Commons a few years ago. And the other one is a crowdsourcing tool for the tagging of images, the ESA tool, which has been developed in the context of Wiki Africa. And within one of the students' projects, we actually created the first proof of concept combining the two, actually creating a crowdsourcing tool that would take on tag suggestions from the computer aided tagging. And now, like this first algorithm from the CAT tool, it actually uses Google Vision, tries to extract entities from the image itself. Whereas we also noted that many images already do have valuable metadata, and we should also find a way to leverage this existing image metadata. So the idea then was to kind of add another algorithm to the tool that would kind of extract entities from the existing metadata. That's also making use of all the effort that has already been put into these images, either by the heritage institutions contributing them or by the Commons community. To set up the next step of the project in a more professional manner than just within student projects, we decided to partner with Switch. Switch is the infrastructure service provider of Swiss universities, and they have been building a so-called Connectome project or research data Connectome project, and their main application currently is the so-called Open Data Navigator. So the idea is to provide data sets, all kinds of data useful for researchers and also in education. Can be publications, can be further things. And in the context of this project, obviously the idea was to also connect images to this knowledge graph. So Switch is a foundation that has been created by Swiss governments and Swiss universities when the internet actually started to come into existence as an infrastructure service for higher education and research. They want to enable, maintain, and promote a secure and networked research and education infrastructure in Switzerland. So it's a perfect partner for us, then also to reach out to the entire digital humanities community, to be connected to universities, etc. The further project partners were Wikimedia Sverige, which had kind of officially taken on the maintenance role for the ESA tool, and they then also mandated software developers and power users of the ESA tool that previously had partly been acting in the volunteer role. And there were like two university partners, the Bern University of Applied Sciences and the Bern University of the Grisons, both from Switzerland. And the project goal, as you can imagine, was to implement a prototypical solution for the semi-automatic tagging of images on Wikimedia Commons using this ISA tool, the Google Cloud Vision functionality, and a newly developed algorithm for the extraction of entities based on metadata. You have here the link to the project website. The final project report has also been published a couple of weeks ago. Now, so that you can have an idea what the ISA tool is about, I would like to give or try giving a live demo. I think for that I need to stop sharing and then share again. Let's see whether that works. It's always fun to do live demos on these online conferences. So that's the homepage of the production version of the ISA tool. Just a first disclaimer, it does not have the newly developed functions yet, but it's just to give you an idea how it works. So you actually choose a campaign. It's based on campaigns that sit on categories on commons. So I'm now trying to take the third one, architecture in Geneva. So I click on the campaign and I should see, when I click get started, I should see images where I'm asked to select an element to describe what it depicts. So I was lucky, I got an easy one. And I even get some suggestions here from, but I think that comes directly from I don't know actually why it's so easy hit. These were not suggestions the way they should look in the new tool, but apparently it already works quite well here. For these very easy ones, I hit save, and then it should directly write to Wikimedia Commons. So if you then go to Commons and in the edit history, I will maybe not go that far because I might lose the screen sharing if I move too far here. If you look in the edit history, you will see that the edit has already been registered there. And then I just move to the next image, and here I have the quarter of Oviv. Let's see a district of Geneva. I'm not going to search for more stuff. I'm just sticking to the easy ones for now. And I stop sharing this screen and come back to my presentation. Okay, presentation view. Yeah. So now the technical solution of the new tool looks like that. It has the elements which you have just seen and this is like the ESA tool. It's connected with Wikimedia Commons that has been demonstrated as well. We take pictures and then depict statements into Wikimedia Commons. The depict statements always refer to Wikidata items. So that's how the three are connected. And what we added now, in addition, in this in the enhanced version of the tool, are two algorithms that bring up suggestions that users will have when they use the tool. One is called the metadata to concept module, taking out entities from the metadata, and the other one is the Google Cloud Vision. And as you can see here below, the user will have access to this tag, to these suggested tags, and can then decide whether they accept it or reject it or just leave it. And then the idea is that the users will become much more productive when using this tool. They don't have to really look up themselves in the metadata. You will have suggestions already. So that's how it looks for the user. It's a screenshot. And the current state of implementation is the following. Like, the test version of the enhanced tool has been deployed at the website that's shown here. It has been working quite okay last winter while we were doing user tests. But currently the situation has become worse. It's not very reliable. The tag suggestions from the algorithms are not always working, and saving tags is also not always working. So you can play around with it. Maybe you're lucky, but don't worry if you're not lucky. It's not your fault. It's the fault of the implementation, of the current implementation. We have identified a series of potential causes for the issues encountered. And unfortunately, there's not sufficient resources currently at Wikimedia Sverige to address bug fixing in a rapid manner. So it has been delayed. We hope to pick it up sometime the coming month. But as you can see below on this slide, like, there's this production version of the tool, which I have just shown you, and I was really happy. I'm really happy that it's working again, but it has actually stopped working between May and August 2023. And we really had to focus on those, or Wikimedia Sverige had to focus on those maintenance issues before actually picking up work on the research and development project again. So what are the key learnings so far in the project? I think the very obvious one is that we need to fix these remaining performance and reliability issues. Otherwise, there's really no way forward. It was already quite a frustrating experience that the production version went down this year. It's very annoying for our lead outreach people when you kind of set up a workshop or present at the conference and then the thing is not working. We really need to get this fixed first. Then we need to put in more effort into increasing the visibility and take-up of the tool among potential contributors. I think there's a big potential that lies kind of unused. But we also found that it would be good to have a monitoring and an evaluation of the relevance of this ESA tool, maybe then also the enhanced ESA tool with semi-automatic tagging in comparison to other tools and methods that are being used for adding structured data and comments. So let's, for example, take a step back and think of the whole situation with this switch data infrastructure. Like, from the point of view of researchers, I think it does not matter whether the data actually gets added through the ESA tool or through another tool. We just need very effective and efficient methods of adding those tools. And we need research and a good basis, an empirical basis, to know which tools we want to advise people to use, and which tools are reliable, which tools have an organization behind that actually maintains them. Another important aspect we identified was that there is not absolute agreement among the community on commons what constitutes good tagging of images. And we need to further have this dialogue and discussion with the community, I think within the Wikimedia context, but then also with other users like digital humanists to see what actually is good tagging of images for them, what is useful, what is less useful, what practices should be avoided. Then this algorithm which we developed ourselves for the metadata extraction, it should be further improved. We have just set up a first proof of concept for that. And we might also work towards replacing the Google Vision algorithm in order to kind of move away from the proprietary approach. Then with regard to the research use cases, we found, well, we talked to various researcher teams in Switzerland, and we found that many of them are actually working with images, often also photographs, that have either problems related to privacy or issues related to copyright, which prevent them from being uploaded to Wikimedia Commons. So the idea as we move forward would be to have a separate media repository that would still make use of this of the crowdsourcing tool with its algorithm, would still link to Wikidata, but would also have media files outside Wikimedia Commons to allow researchers to work on them in the settings that they are allowed to actually work in. And last but not least, we need to clarify the roles and responsibilities with regard to the deployment, operations, and maintenance of this tool if we want to take this a step forward, also in partnership with larger organizations. We need some sort of a service level agreement, and we need to be sure that these tools are actually being taken care of if they break. So I will finish with some reflections with regard to the wider community discussion. I think it's relevant here at WikidataCon. It's probably as relevant also at the GLAM Wiki conference later in November. I think it resonates quite strongly with some experiences that have been made elsewhere as well regarding tools for the GLAM sector. So just to recall the two main goals of our strategic direction for 2030, knowledge as a service and knowledge equity. I think this project and this service we're trying to develop here it really falls into the first of these goals. Like, we're trying to build software infrastructure in connection with Wikimedia Commons, in connection with Wikidata, that serve a community of users outside our movement, but with a lot of synergies with our movement. Regarding knowledge equity, I'd like to point out that the ESA tool originally has been developed in the context of Wiki Africa. We even had a developer on board who actually works from Africa. The main test users came from Africa, so I think we're also doing quite good on the entire global South perspective. It's important to us also to create software that is not just useful for people in the global North or for universities in Europe, but also for any user within our movement that may contribute images and image descriptions. So despite of all that, somehow it turned out that our partner organization wasn't sufficiently reliable as we expected. And I don't blame anybody here. It's not about kind of looking for people to blame, but it's just some reflections as we move forward, what we need to make sure that we get this properly organized in our movement. So for R&D projects, we need reliable partner organizations, and these respective movement entities need to be empowered for this role. This means they need to have proper financial planning that goes across several years, proper resourcing, and especially the roles between movement entities need to be clarified. Ideally, chapters would work hand in hand with the foundation and other partners. I also think, and that's not just true for this tool, but for other tools as well, within the GLAM wiki field especially, that maintenance and development of important tools and services need to be backed up by an organizational commitment. It's not enough to just have tools being developed and maintained by individual volunteers. We're just too much exposed to the risks of somebody not being available, somebody having different interests, somebody maybe not having the necessary skills to address all the issues that may come up in connection with the tool. I think we really need to take care of that as a community, as organizations. And the last point, we should become experts in navigating between the volunteer and the paid staff worlds. We need to develop a shared professional culture that englobes both of them. So I think that's a very important strength of our community, to be able to combine the two worlds of volunteer developers, volunteer contributors on one hand, then we have paid staff, and then we have on the other hand also partners that interact with us that often have paid staff, and sometimes also, like if you go into the research field, also work with students and in less formal environments. And I think that's a strength which we need to strengthen as we move forward, and we need to become better at that as well. So the outlook is we want to include structured data on commons in the Switch research data connector. So to make all this data on commons also available to researchers in Switzerland. We need to fix the remaining bugs of the enhanced version of the ISA tool. And we want to further develop the metadata to concept algorithm. And I'm going to have a kickoff meeting for that with the students project at the University of Virginia School of Data Science on next Monday. Thanks a lot for your attention. I'm happy to take your questions, and I will stick around also after the presentation. You can approach me in the meeting space if you want.
Thank you, Beat. We open up the floor questions to the participants. So while everyone is thinking about some questions, we have a hand raised. Just want to check. To Ka, do you raise your hands just now? Or do you accidentally raise your hand? Okay.
Alan, we have actually a question from the chat.
In the chat, that's
from
correct.
Yuchen Lin. One weird question. Let's say if there's a label or meta information of a picture from Wikicommons, can Lexemes able to index this wording? For example, if I have a picture, it has a meta property stated blue, Geneva. Am I able to index this picture at Lexeme or ISA in other languages searched by Azure Gem?
I'm not quite sure whether I fully understand the question.
Can Lexemes be able to index this wording anyway? This is
So I will try to answer in several steps, and then maybe the person who asks the question can jump in again to further elaborate on the question. So what we do, we link these tags to Wikidata. So Wikidata is multilingual. So for the use of the data afterwards, that's good enough. I think we just need to ensure multilingual coverage of Wikidata, and we link to concepts and not to Lexemes. Now, when it comes to the metadata to concept extraction module, we are currently struggling strongly with the recognition of the language, because often the the text bits that are in the metadata don't represent full sentences. So imagine if the potential of number of languages is above 100 and you just get a few proper names with a few words in between, it's very hard to guess the actual language, which means that it's hard to treat it with computational means. I think we will have to address this issue as we move forward. Another approach would be to always explicitly provide the language of the metadata. Some institutions do that when they upload images, but I don't think it's standard on Wikimedia Commons to actually provide the language. And what makes it actually worse is that on the same Commons page, you can have different fields in different languages without this being properly declared. Now, would Lexemes help there? I'm not entirely sure. Maybe. I don't know who asked the question. Yu Cheng Lin, do you wanna jump in? Did I answer your question?
Yes, Yu Cheng is.
Oh,
Right.
yes. Yes, my question is, that's my question, but connection problems. Oh, this is
Okay, seems not to work. So the approach which I will probably suggest students to take, and I mean we have several. We have, if you read the report, we have about 6 or 7 strategies identified how we could improve this metadata to concept part. Regarding the languages, like my idea would be to take a few main languages that are easy to distinguish from each other. For example, like it's very hard to distinguish between Italian and Spanish, but it's not so hard to distinguish between Chinese and Arabic. It's very easy. So we might go with a subset of languages that are easy to distinguish and then at least have not just English support, but support for maybe 10 languages that we may be able to distinguish via the script or some other particular feature. Any other questions? Oh yeah, Lydia gave an answer as well. I would rely more on labels on items than Lexemes for this. Yeah, probably. Yeah.
So there's one question by Chris Baum on how does this project relate to, and there's a link that is being shared there. So maybe if it's possible,
Yeah.
we should click on the link to see.
Oh, it has been disabled, it said.
Yep, that is correct.
Yeah, it's
okay.
computer aided tagging, which
Yeah.
is it's a tool that has been recently disabled.
Okay, I don't know whether the entire tool has disabled. I hope not. Otherwise, I would have expected that they tell us in advance. We actually use the same API. There's a Google Vision API implemented on Commons that is being used for this, or has been used for this computer-aided tagging tool. It has currently from the point of view of our tool, the limitation is that you always need to first include a given category into Google Vision, Google Cloud Vision, due to licensing issues. They cannot apply it to all the images on Commons by default, so it's also a subset that makes it a bit tricky. But otherwise, it's the same tool, and for sure, we need a human in the loop. It's not, you can't go for anything automatic. And I think when the computer-aided tagging tool was introduced at the beginning, some community members complained because the newly added tags did not correspond to some community rules, what constitutes good tagging. What we found is that if you enter a dialogue with the community regarding good tagging, you will easily find that people have varying ideas. They don't always agree. There's, I would say, a rather conceptually clean approach proposed by some proponents on Wikidata, and on the other hand, you have a very pragmatic approach that is taken by the search team at Wikimedia Foundation. And that is also a bit due to the fact that the entire ontologies on, like what we discussed earlier today, the class trees are not clean on Wikidata, so it's very hard, or it's not very useful to infer too many things based on this information on Wikidata. So the search would rather have more direct information on these images instead of trying to analyze the graph. So there's philosophical questions behind that when using this tooling, and when using new tools to add tags. What we think we could achieve in the ISA tool in the longer term is that we can try to find out what are the good community rules, and then try to see how we can nudge the users in this direction. But we can, currently we're using some block lists to avoid practices that are really frowned upon by the community. But that's where it stopped so far, because as long as there are no clear guidelines for community members, it's also hard to see whether the tool actually works in that sense or whether it counteracts these guidelines. So I hope that's
Thank you.
Answer enough for that one.
Thank you, Beat. And I believe we are out of time. And thank you everyone for your question. And if you have any further question, please feel free to move your avatar to Beat later on after he comes off the stage, and we can have different conversations. As you can see, this is the wonderful thing about this platform, GatherTown. So thank you, Beat.
Thanks a lot. Take care.
Take care. And we will take a short break, I think about 10 minutes, slightly more than 10 minutes break before we have our next session, Dicothèque, explore and compare dictionaries on the French Wikisource. So see you all in a very short while. Hello everyone, just a gentle reminder that our next session will start in approximately 3 minutes time. See you in a short while.
Wow.
Hi everyone, welcome to another session for today. The next session title is Dicothèque, Explore and Compare Dictionaries on the French Wikisource. Our speaker for this session is Poslovich. The floor is yours.
I hope everything's working.
Yes.
I sincerely hope it does. And I'm trying to set up the screen share.
Yes, we can hear you.
Okay. So let's get started with the screen share then. A full screen. Authorize. Oof!
Yes, we can see your screen as well.
Yeah. Great. So, a few quick things before I start talking. This talk has had many various iterations, and we've had a last-minute issue. So it was supposed to be presented by both me, Poslovich, and Lyokoi, which is also someone that worked and works on the Dicothèque, but he had some last-minute issues. So I will be alone tonight to showcase you this thing we've been working on together for the past year. So the Dicothèque is a tool that will allow everyone. For now, it's limited to only people who have an account on Wikimedia for technical reasons. I will explain in a short time. This will allow everyone to explore and compare dictionaries on, for now, the French Wikisource, but we also plan to expand that out. So, and it's not working. Yeah! So, the Dicothèque, what's that? It's a tool that's available on the French Wikisource for now. So I just need to get out of the full screen, get back on my computer and show it to you. So it's all written in French. Hopefully that won't scare you away. This is a special page, not in the meaning, in the technical meaning of MediaWiki. It's a page on the French Wikisource, which requires a user script that you need to put into your command.js to run. And this page allows you to get access to 28 dictionaries that are currently available on the French Wikisource. So all of these dictionaries that you can see on the right-hand side are dictionaries that were worked and entirely transcluded on Wikisource. For those who don't know how Wikisource works, you get a book which can be in the form of a PDF or déjà vu file, which you then read and proofread page by page. So here I have the 28th page of this book, The Dictionnaire raisonné de l'architecture française du 11e au 16e siècle, which is a dictionary which is in the public domain. And we then have this page, which comes from the scan, and we then have this page on the left-hand side, which is where we copied and proofread the content of the page. This way, the page gets stored as a text file, which then gets transcluded into the main namespace, both per volume, but also per letter. And each and every one of the articles of this dictionary, each one of the entries, then gets transcluded as its own entity. So they all get their own subpage, and this is the main unit that the Dicothèque works on. And so here we can see the entry for accoudoir from said dictionary. So actually, we're going to test that out. We're going to search for accoudoir. Hopefully it's going to work, and it does. Sadly, it has failed to find the entry from the dictionary I showed you. But what it does is that it searches for every entry that is the same string, the same word. And so this way you get a side-by-side comparison of various dictionaries and how they describe the same thing, the same word. Maybe I can check another word. So orgue, which mostly is a musical instrument, which is called organ in English. I don't remember how it's called in German. But so there you have the encyclopédie, which is one of the, which is like the precursor of Wikipedia from the 18th century in France, which has a rather long article about orgue. You also have one that is about orgue de mer, mostly some kind of seashells. And if you go down, because this is a long article, long, you get also an entry for orgueil, which is a word that has absolutely no meaning related to the organ, the musical instrument. It's just that the Dicothèque works by default by searching anything that starts with what you're querying. So if I just say strict research and just search there, I just get orgueil. So that's basically what it does and how it works. You have your list of dictionary that are here, and you then get the ability to filter them by date, by publication date. All of this is based on Wikidata, as well as various filters you can use for the gender of the dictionary. This is mostly about what it looks like, how it's written. It's a bit complicated to find the definition in English. And you can also filter by subject. So we have some dictionaries that talk about Breton, which is a French regional language. What do we have? We also have here selectors, particularly for languages. So this is how it works. This is a prototype that I've been working on since almost the beginning of 2023, and haven't touched for about a few months. But it shows that this is working. it can work. It can be used. Excuse me. So yeah, I'm having a bit of trouble finding my words there. Yep, there we go. Oh, what the hell? Found a bug. Live demo always help find bugs. Anyway, so let's get back to presentation. So now I would like it to work properly, but I don't think it's going to allow me to do that. Oh, yes. So what is Dicothèque in a nutshell? This is a search engine and a comparison interface. As I showed you, it allows you to search for words in dictionaries that have been transcluded on Wikisource. So for now, it's only the French Wikisource, but that's merely as a proof of concept stage. This idea of having an interface that allows to search through all of these dictionaries was proposed in 2022 by Yokoi at the Wikipedia Convention Francophone, and I started working on it in early 2023. And what's interesting and why we decided to showcase it to you today is mostly because it's powered by Wikidata. It makes heavy use of Wikidata in the way it works. So how does it work? Well, how do you add content to it? Because this is mostly where all of the Wikidata related stuff happens. So as I said, you first start by proofreading dictionaries on a Wikisource, in this case the French Wikisource, and you transclude them. So you split the pages and publish the pages on the main namespace, with the rule that one word, one entry, because dictionaries sometimes put multiple words in the same entry. So one entry equals one page, one sub-page of the dictionary. This is done so in order to allow for easy searching, programmatical searching through all the text that happens, that exists for a certain dictionary. Then once you have your dictionary transcluded, you create their Wikidata elements, like you pretty much always do regarding a book that's transcluded on the Wikisource. So going back again to the Dicothèque, you can see here that each dictionary has an edition, so edition, version in English, and a link to the work, the l'œuvre, the œuvre. So edition is the Wikidata item for the version of this book, so the year it was published, and the work as well, which also provides generic data about what the book is about, what its gender is, what are the main subjects. And you can therefore notice here that this data is what powers the filters. The filters on the Dicothèque, so subjects, genders, and languages, are powered by what's inside the work items for each and every book that we have here in our list. So if I take this dictionary, which is a dictionary of another regional language of France, here you can see that language of the work is French and Lorrain, which is a northeastern regional language in France, and also the main theme of the book. And therefore, if I uncheck everything and pick Lorrain, the dictionary that's available is said dictionary. So this is where Wikidata comes into play with such magnificence. It really is a practical resource when you use it that way. So once you have the Wikidata elements, you add the addition QID to the list of dictionaries that the Dicothèque works on. And then you just reload the page and it's there. So you can start searching and comparing. That's as simple as that. The most difficult thing, of course, is to proofread and transcode the dictionaries. It can take days, weeks, months, sometimes years. I've got the example of one of them. The last dictionary I showed you, I'm still working on it, and I've been working on it for about 2 years already, and it's not entirely done yet. So how does it do its work? I won't dive into all the technical details because it's, as I said, a proof of concept, and I don't want to bother you with all the techno babbage, boring stuff that some of you may not appreciate. But basically, this is a Vue.js app, sort of, because it's not, it's using something that's been introduced into MediaWiki in the past few years. So MediaWiki now has Vue.js built in, but in a way that's a bit weird to make use of. It's easier to use it if you're an extension. But in my case, I am a user script. So I have some really weird stuff to do and make so that it works. So this is mostly because of all this quirky stuff that I won't dive deeper into how it works. But this app then gathers all the information about the dictionaries that we have in our list. So this is where it does all the work. It gets the gender, the genre, the languages. It gets also labels as well. So if we want to translate the Dicothèque into any language, as long as the labels are available, we could technically do so. And this is what's great also with using Wikidata for that. And then it queries the Wikisource. So it makes use of Elasticsearch capabilities, most notably of Cirrus Search, for those who know about this thing. This is the extension that allows you to do some magic search queries into the Wikisource. So as an example, in title, colon, whatever, which allows you to check only for words or sequence of characters of chars that are in the title of the page. And I make extensive use of this functionality as well. So this is really a basic overview of how it integrates into both Wikisource and Wikidata. So what's next? What will happen to La Dicothèque? It's, as I said, it's a work in progress and it's a proof of concept. And it has done its job. As a proof of concept, it has shown that it is possible to do. And we're very happy about that. But we also are a bit limited in what we can do due to all the technical quirks. So we obviously want to go international. Having it in French with French dictionaries is interesting because with 28 dictionaries, with the 28 that we have now, we are one of the, if not the most extensive dictionary search engine that exists today. We have the CNRTL, which is a laboratory, a collection of tools made by a French laboratory, which has a tool that provides search capabilities in 7 dictionaries. We also have the Dictionnaire des Francophones, which allows searching through 8 or 9. but the Dicothèque, which is entirely powered by Wikisource, so by volunteers that have worked on dictionaries of any kind for a few years, now has 28 dictionaries, and this is up and counting. So it really will be able to get extremely large, extremely quick, given the nature of and the collaborative nature of Wikisource and the Wikimedia movement. So either we natively support all the Wikisources, so we develop and deploy a Dicothèque on all the Wikisources that exist, or we find one place to bring them all and in the likeness bind them. So maybe have a dedicated website. I have absolutely no clue there. Obviously, if we want to go international, we have to translate the interface, which is already quite easily done and doable thanks to Wikidata labels being internationalized. And of course, if we want the Dicothèque to grow bigger, we will need to have more dictionaries in all the languages of the world. So that's about it, about La Dicothèque. Thank you for your attention. You can get in touch with us. So with me, with this email address, I will be checking in quite often, especially if it's to talk about the Dicothèque or maybe the technical aspect of things. Yokoi can also be contacted with this email address. And if you want to, there's a Git repository that's available on the Wikimedia GitLab, where you can find the code that's not web-packed, because the code that's currently deployed on the French Wikisource is web-packed to ensure it is more compact, because the app is getting quite heavy right now. So yeah, thank you for your attention, and I hope I have given you satisfaction with this talk. Whoops, May.
Thank you, Poslovich. Anyone has any question, please feel free to press the hand raise button that you see next to on the smiley face option. Otherwise, you can also just type in your question in the chat and I can read it out. Then we can all hear. Does anyone has any question?
I have a bit of trouble hearing you.
Can you hear me?
Yeah, it's fine.
All right, great. Sorry. So does anyone has any question? Please feel free to raise your hands, or you can also type your question in the chat as well. Just let me look into the chat section.
Okay, so I have seen a few things. So, of course, the German for organ is Orgel. My German is quite ancient. Blah, blah, blah. The work genre in agenda. Yeah, sorry, Vigneron. Being able to search all the dictionaries would be amazing. Of course, Nikki, it would. And this is why this idea has been proposed. And I've sort of jumped into the idea by starting to make it a reality. Getting it out of the idea realm and turning it into a reality. Theo, English is hard tonight. Where to put this kind of services? Should they be on ToolForge? Honestly, ToolForge is a very, very powerful tool at our disposal, and they absolutely could be on ToolForge. The main issue with ToolForge being that this is not natively on-site. What I mean with this is that things that are on ToolForge are mostly used by contributors of Wikimedia wikis, and not by viewers of said websites, which is why this is more like an identity issue of having it available on ToolForge, because it wouldn't be as visible as I wrote my sentence. It wouldn't have the same visibility, the same outreach as the things on Wikisource. Right now, we have a page on the French Wikisource, which is Wikisource : Dicothèque, which may not be the most visible, but it's way more visible than ToolForge. Yeah, of course. Yeah, of course. I don't really know, because I'm not that much of a techie pro. I remember you can do some redirection, but yeah, having it run on ToolForge will also allow some sort of caching of the data, because right now it fetches everything all the time, which is a bit of an issue if you use it on your phone on mobile data plan. But yeah, as a proof of concept, it works. It needs some polishing, of course. But yeah, maybe it should be on ToolForge. That's a very good proposal. Yeah, sorry, Vigneron. Sometimes actually it doesn't use the Wikidata query service. It uses basic, it does the queries on the entity data, or whatever endpoint that is, the one that just gives you the entity data for say URI. This German dictionary in the Wikisource, which already has entries split by page. Oh, that's interesting, Nikki. Yeah, that's what I thought, Tuka, because at Wikimedia France, we have a service that's on the ToolForge, but we just do a text DNS redirection. We just redirect to the ToolForge name, but it does not have the actual DNS then. Yeah, interesting. I'm a bit sad that Lyoko isn't here with us, because you all brought out some interesting ideas. Just going to get that thing into my notepad so I don't forget about it. Very, very interesting.
Okay, I think there's no further question.
Yep.
Or if people want to have a conversation with you later on, please feel free to come off the stage, and then they can all come near you with their avatar.
Yeah, of course. Thank you for listening again. And as I said, I'm available under the same username on Wikimedia. And if you want mails, you can contact me by mail. So yeah, thank you for your time and your listening. It was a pleasure.
Thank you for your session as well. Yes. Bye. So we have another about 15 minutes break before the next session. Wikifunctions fulfilling one of Wikidata's missing promises by Danny. So it'll be about I think slightly more than 15 minutes break. So I hope to see everyone again later for the next session. So thank you.
From up here, I can annoy everyone.
Well,
But I
that's the
can't
point
hear
of
you.
being on stage.
What are you saying?
That's the point of being on stage.
Indeed. So, but we still have 10 minutes.
Yeah, in fact, yeah, we are still a long time. I will call the panel in 5 minutes.
But it's a one-way thing. I'm not hearing any of you besides Luca because he's also in a loudspeaker place. Okay.
Yes, in order for
yes,
someone else to be heard, they should be either on stage or they should be given the possibility to actually talk, which I don't remember how is it.
All right. I hear that, yes. Okay, but probably not everyone else. So I'll step away from the things so that I'm not blocking any other conversations. See you soon.
Just briefly to remember everyone that in 5 minutes, the new session Wikifunctions fulfilling one of Wikidata's missing promises is going to happen here in the main room. Also, a brief reminder that if you want, you can write your question in the chat, or you can use the raise hand feature right after the webcam. There is an emoji button, and then if you click on that, you can see several emojis. The far right one is the raise the hand. So if you raise your hand, we can give you the possibility of speaking out loud and ask your question out loud. But only if you want, of course. If you don't want, if you don't wish to talk, you can write the question anyway. All right, welcome back to the WikidataCon. Oops, sorry, my webcam was not on. Apologies. So, welcome everybody. Welcome back to the WikidataCon. This is the last part of our day 1.5, and I have the honor of introducing Danny Brandicic, co-founder of Wikidata, founder of Wikifunctions. You know him, of course. So there's a little point for me to actually explain to you who is he. So I give him the floor to present the new project that has been launched last July, which is called Wikifunctions.
Thank you, Luca, for the introduction. Thank you all for being here. I'm very happy to for you to having me for the program committee to accept the presentation. Wikifunctions, fulfilling one of Wikidata's missing promises. I will explain what the title means, but first I want to introduce Wikifunctions a little bit. Wikifunctions is the first new Wikimedia project since 2012, and a certain other project has started that we are celebrating here today. Actually, the birthday is coming up, like, I think tomorrow, right? Today, I'm not exactly sure what the definition is. Wikifunctions is just like Wikidata, fully multilingual in terms of natural languages, but also it aims to become fully multilingual in terms of programming languages. We'll see that also in a bit. And it's a wiki for functions. What does it mean? What is a function? So let's take a look at Wikifunctions. Actually, I don't have to talk about Wikifunctions in complete hypotheticals anymore. I can actually go to the website and show it. So this is the main page of Wikifunctions as it currently is, or similar to it. And what you see here, there are quite a few functions that are being pointed to. There's a bit of intro text and so on. And let's take a look at how one function could look like. I'm taking intentionally a very simple example in order to make it understandable. This is the not function. Not or negation takes a Boolean value. Boolean means that it's either true or false, and that's it. That's the only two possible values it can have. So it can take either true or false, and when you run the function, you should get the other value. So basically, if you run it on true, you should get false. If you run it on false, you should get true. That's how negation works. Now, if you look at the negation function and how it is done, so we see that we have two tests, unsurprisingly, because we have two possible values. True negated is false, and false negated is true. Thanks, Nicola, for the links. This is really awesome. And then we have three different implementations for the not function. We have one implementation in JavaScript, one in Python, and one in composition. We'll go through all three of them. Let's take a look. So in Python, it's just saying not. So return not of the value that you got in, and that's it. So we have a bit of code which is being actually run, and this is how the negation function in Python looks like. In JavaScript, it looks pretty, it's very similar. We have also a little bit of code here. We have an exclamation mark instead of the not keyword, because this is how JavaScript implements it. But that's basically it. Now, composition. Composition is not a brand new programming languages or whatever that you haven't heard about. It's actually just means that we're composing existing functions together in that are already there in Wikifunctions. And in this case, it is the if function. The if function has three parameters: a condition, a then in case the condition is true, and an else in case the condition is false. And the condition is simply the value to be negated, the value that the one argument of the negation function. So if what is being given in is true, then return false. If otherwise, return true. So this is the thing. This is how it's implemented. As I said, I was going intentionally for a very simple example. Now the thing is, in composition though, everything is built out of objects that we have in Wikifunctions. And just like in Wikidata, all of these actually have IDs. We don't have QIDs, we have ZIDs here. But they are just, IDs with labels, just like in Wikidata. And this means that we can, just like in Wikidata 2, just switch over the view of this page from English, for example, to Polish. And have everything there being in Polish. And just like in Wikidata, it's not just for viewing the whole thing, It's also for editing. So you can actually edit functions in your native language. You can contribute functions in native. You don't have to speak English in order to start coding. And this might be for many people the first time that they can create code in the native language. So with Wikifunctions, we want to allow implementations of functions in English. We aim to bring functions to a whole wider pool of people, to a large pool of potential contributors who have all the skills necessary to contribute functions but don't speak English yet. We hope to unlock the potential. We hope to grow a new community. We hope to bring in new contributors by supporting a new form of knowledge. And we really want for Wikifunctions to democratize access to functions. Today, programmers have easy access to all kinds of functions, but others only to whatever some big tech companies allow them to have. Wikifunctions, we want to democratize the usage and also the creation of functions to enable many more questions to be answered. So this was a very simple function, as you have seen. And the nice thing about Wikifunction is, so what we aim to do is to actually integrate Wikidata into Wikifunctions. What does that mean? We want to be able to use the knowledge that is in Wikidata to answer functions. And the following is a mock-up. Here's how this could look like, for example. So we could have a function that asks, did they live at the same time? And it takes 2 taxa. And just to take an example, I'm taking my 2 favorite dinosaurs. I guess if you have kids or nieces and nephews, you probably have a favorite dinosaur. So mine are Stegosaurus and T-Rex. And you can ask basically, did Stegosaurus and T-Rex live at the same time? And here we get into a little bit of trouble, because in Wikidata, things are not always modeled in a consistent way, right? So we can take a look at Stegosaurus, and Stegosaurus has actually a start time and an end time, 155 million years start time, end time 150 million years BC. Okay, that's good. But what about T-Rex? Well, T-Rex doesn't have a start or an end time. It doesn't actually have anything about time. What it does have is that it says that it's a parent taxon, that it has a parent taxon, which is a Tyrannosaurus. And Tyrannosaurus, in turn, has a temporal range end and a temporal range start, which is the Maastrichtian. And the Maastrichtian, and in turn, has a start time and an end time. So we can actually conclude that they have lived between 72 million and 60 million years ago. And we can answer the question that we see that, for example, that T-Rex and Stegosaurus did not live at the same time, not even close. In fact, humans and T-Rexes are quite a bit closer than Stegosaurus and T-Rex are to each other. And we can get this information out of Wikidata, but it's a bit difficult because the modeling isn't really consistent between all of these. So we could then ask a function to Wikifunctions, and once we can then link to Stegosaurus and T-Rex, it could try to look up all these different possibilities how it's modeled. Or, and this is now the interesting thing, where in the Wikifunctions and Wikidata would start to interact with, it is kind of a forcing function for Wikidata to become more consistent, just like Sparkle queries already are today, and any other use of Wikidata is already today, trying to make the modeling more consistent. But we can also make the function more complex and trying to account for different modelings. And this is where the 2 communities will have to work together in order to figure out which way they actually want to do. So there will be a lot of considerations around how to use Wikidata, how the modeling can be maybe done more consistent, how those things can be working better together. And there's a lot of stuff we can discuss about this. So, but how is Wikifunctions then going to be used besides answering questions on the website? So one thing that we're aiming for is that already today in Wikipedia and other Wikimedia projects, you have a lot of functions being used. So for example, if I go to the page of Audrey Tang Fan, who's part of the government of Taiwan, there we see that it states age 42. And this 42 is in fact calculated by a function which is currently implemented through a module in the English Wikipedia. And we have many of those modules across all the different projects. We have about 800 projects, and we have this module implemented about 80 times or something like this. And most of them are just actually copy and pasted from each other at a specific time in play, at a specific point in time, and they're not being kept up to date. So if there are fixes in one, they're not necessarily being carried over to the other languages, and so on. So we have a lot of different versions of the H module and names of that. And they're also named differently. They have maybe different parameters. So you can't actually just copy and paste them from one wiki to the other, because you might have to actually have a different name or even have a different functionality. And one of the goals of Wikifunctions is really also to centralize this a bit more. So just like Wikidata centralize the site links, I guess some of you might be old enough to remember the fact that the site links were not used to be centralized. Just like Wikidata used to centralize the site links, Wikifunctions aims to centralize some of these functionalities that modules provide, the templates provide, and make it accessible to all of the MediaWiki projects at the same time, and in a way that is actually easily copyable and copy-pastable from one wiki to the other. So instead of having all these 80 different modules and templates, we would just have one function, which is internationalized and which can just be called from any of the wikis, and which would display then result in the wiki, in the given wiki. So this is how we want to use data from Wikidata, maybe images and data files from Commons and Wikifunctions, and make it available in all of the Wikimedia projects. To have a pipeline where we can create and take data and create text with high confidence, with high fidelity for the different Wikimedia projects that we have, so that everyone can share in those. So, what does this have to do with any promises from Wikidata? The hook in the talk. What are we here talking about? So, about 12 years ago, 13 years ago, roughly, when we wrote a technical proposal for Wikidata, the proposal was separated into 3 different phases. The first phase was to unify the interwiki links, the site links. As I said back before Wikidata, all of the different Wikipedia articles pointed to all of the other language editions of Wikipedia that had an article about a specific topic. So if you had an article about Taipei in the English Wikipedia, it would probably point to about 100 different language editions of Wikipedia and saying, this is the Taipei article in the German Wikipedia, this is the Taipei article in the French Wikipedia, this in the Chinese Wikipedia, this in the Hindu Wikipedia, etc., etc. And then in the Hindi Wikipedia, again, you would have basically the same list. You would say, this is the one in the English Wikipedia, the German Wikipedia, and so on and so on. So you would have this list of 100 Wikipedia articles, slightly different because you don't have the one Wikipedia where you're on, in all of these being copy and paste. And a lot of this was done by bots and kept up. In many Wikipedias, actually, the bots were responsible for about 80 to 90% of all edits on those wikis because the site links were not centralized. So the first phase of Wikidata back then was to bring the interwiki links into a single place, Wikidata, and then have the articles call them. The second was to support the info boxes, which then turned into statements, and the statements could be used in the info boxes. And we are still definitely in the phase of implementing that, as you know. In a growing number of Wikipedias and other Wikimedia projects, we have a growing number of fields which are being used to fill the info boxes. And Wikidata has since grown well beyond what is needed in the info boxes and has much, much more data about all kinds of things, and is used in many, many other things. But the original proposal didn't actually stop here. It also had a third phase, phase 3. And whenever I bring it up to Lydia, she winces. So phase 3, we called back then lists. And the idea with lists was that you can have a query and display the query result inside of a Wikipedia article. So this is something basically that data was actually fulfilled in many ways with, for example, with Sparkle. So in Sparkle, you can ask a lot of queries and you get beautiful visualizations of those. The part that is missing is that those query results actually not being integrated into Wikipedia. What you see here is a query for mathematicians and the theorems, and display them by dev date of the mathematician, which I stumbled upon recently, and I find just one of the most beautiful queries that we have here, really. Here another one. This shows you the etymology of the word water, and other words that were coming from the same Proto-Indo-European root down here. And show you. This is a query over the Lexemes that we have in Wikidata, and displaying you the connections between those. Here, this map is created out of a query, so no coding or anything. It's just a query asking for glaciers in Central Europe. And you get a nice visualization on a map. And again, something that you could totally use inside of an article in Wikipedia, but you can't. Here, the list of capitals of the world by size of the population, and listed backwards, so the smallest first. Again, this is a query that you can just ask to Wikidata. It gets updated whenever you get new data, and the result, there is a Wikipedia article for that, but it's not built on top of this query. There is completely independent of this result. We have Listeria by Magnus Manske, which is kind of a bot that takes Wikidata queries and puts them into a MediaWiki, and you kind of have this kind of thing there, but it's not as tightly integrated into the infrastructure as you would want to have it in order to make this actually a viable path to push the data back and forth. But it's a really great step to show what can be done with those things. And this is now the thing with Wikifunctions. So if Wikifunctions can take data from Wikidata, and the results from Wikifunctions can be integrated into the Wikipedia and other Wikimedia projects, you basically have this path of creating whole query results inside for Wikimedia article. So, and this kind of fulfills the promise of creating lists of or any other way that you actually want to use the knowledge from Wikidata and generate some content or some piece of content that you can then reuse in the different Wikimedia projects like Wikivoyage and Wikipedia. And this brings us together, and this also really then ties the data together, because the data that is not being used has the likely will start falling into being bad, not being maintained, and be more liability than advantage. So using more and more of the data is really the goal here in order to improve the quality of Wikidata, to improve the value of Wikidata. And at the same time, also by having those functions, the functions will kind of force a kind of modeling, otherwise the queries won't work, onto the data, and we will have a give and take between writing simple functions or writing more complicated functions, or having more uniform modeling on the other side, or having more different ways to model. So this is something that the two communities have to talk with each other. So the first thing that we want to work on is, that we already started working on, is we have already some functions for morphology. So for example, here is for the Finnish nominative plural, you enter here the I guess infinitive version, the lemma, and then you can get the Finnish nominative plural of a noun here. And this is the same data that we already see in Wikidata, represented with different forms. So we here again have the same form, and we also have the same data in Wiktionary, often in several different Wiktionaries that have all of the same thing. And we really need to figure out, well, how do these three places should work together? And the function for the regular forms, then we have Wikidata with all the data being in a structured form. We have the Wiktionaries displaying the data, often currently, most of the time actually, containing the data. that's something where the communities have really to get together in order to talk about how to make this a streamline and how to make this the most useful way. One way I would love to see this, for example, use is with Lukas Werkmeister's awesome Wikidata Lexemes forms. That is basically giving you a form in order to enter lexicographical data, to create the lexeme or to edit the lexeme. And here, for example, we connect the, this is the, probably this one here, the nominative plural, directly with the function that we have just seen. And for example, once you enter the lemma, it could just automatically generate the other versions, and you can then just check them instead of having to write them all hand by hand. Another way you can use this, for example, as I've shown previously, we could use the functions that we have and check them against the current forms and see if they are actually consistent. Which would be the case for all the regular forms. For irregular forms, obviously, it wouldn't be. So not okay would not here necessarily mean that it's a mistake. It can just be an irregular form, which happen quite frequently in many languages. So there are many different ways we can use the functions and Wikifunctions for morphology and similar. And how these things are separated is the big question that we will have to work on in the next coming year. Another place I would really like Wikifunctions to be used rather sooner than later, even though I'm not exactly sure how, is for descriptions, because a lot of the descriptions could be just abstract descriptions being created and then be available in all the, I think it's 500 something languages that are being currently available for descriptions. And really a lot of information is, as you know, very redundant and doesn't need to be written so often. So it could be just here an abstract representation. It says something like University in Nigeria or something else, and be available in all the languages that we have then a function for to create those things. How we actually integrate those things? That's a great question. Where do we store the descriptions? Do we materialize them for all the versions? Do we just put them on out of the fly? I don't know. That's something we have to figure out together. And finally, then to bring this together into the Wikipedias, to have the age function, to have more complicated things like the list of national capitals population be created by a function, be up to date with Wikidata, have more consistency across our projects and bring everything together. How this all fits in with the MediaWiki architecture, which isn't really meant for this kind of things, that's something we have, again, to figure out. I know I'm bringing a lot of questions here. And how do we get to acceptance of functional results as content? Listeria didn't have the greatest success in the English Wikipedia, as we know. And why there's no, the functional difference to what we're working with is not that great. So the question is, how do we make it actually acceptable to have functional results being content in the Wikipedias? Again, a question we have to go on. So we discussed about this. I'm pretty much at the end of the project, which is so good because I'm probably over to my time already. So we want to take Wikifunctions and continue building on it, and then integrate Wikidata into Wikifunctions, which will be a huge step forward in order to make use of all the knowledge in Wikidata, and then have the results of Wikifunctions function calls be available in the different Wikimedia projects, so that we can all work together on much more knowledge than we have currently available. Thank you for your attention. Thank you for being here. And join us at wikifunctions.org. The website is open, and we are working on making it more and more available and open. Thanks, everyone. We have time for a few questions, I think.
Yes, we do. And there are already three questions and a comment. But if you have more questions, please write them in the chat or raise your hand, as I told you with the emoji. So straight to the questions. User Ahmad Alvarez asked, will it be just one repository for Wikifunctions as it happens with Commons or Wikidata?
Yes, there will be only one Wikifunctions.
Oh,
that was a short one. We don't plan to.
Okay, so Wise Woman raised their hand. I would like to wait a bit on a question, if it's possible, because there are other that came before, but I will get back to you as soon as I'm done. So user Melderick asked, could Wikifunctions be used to define constraints in Wikidata?
It depends what you mean. So what we can do is, for example, you would be able to create a function that checks an item and tells you, well, this is okay, or no, this is actually problems and stuff like this. So you could create a function that does that. You could create a website or a workflow that uses those functions then in order to display, for example, all the following things have problems. Whether we would integrate it tightly in Wikidata, for example, that those results are available whenever someone edits Wikidata, that's a question for very far down the line, because we need to figure out, like, should we be calling Wikifunctions on the fly while someone is editing, and how do we display this? Might be starting with a gadget or something like this. I can imagine that we can do that, calling the functions over, then checking what is there and so on. But there's a lot of questions like of practicability and how exactly we implement it. In theory, this could be a path to that. In practice, we already have the entity schemas, which are doing a great job and which are getting more and more workflows for these things. Functions would be potentially more powerful, but a little bit more difficult to understand and work on. It's always a kind of balance where exactly we want to work. I would always suggest to use the simplest possible tool for your task, and if entity schemas can do it, it's probably better than writing a function to support that, and only use functions for those places where it doesn't work, and then we need to figure out how actually we integrate those things. So that's a very qualified probably.
Thank you very much. So next one from Rory O'Donnell. I hope I pronounced it right. So the comment is, really like the idea that Sparkle and Wikifunctions are forcing function to improve data consistency. It's a nice way to think about it. But the question is, next step would be function pipelines and integrations.
I'm sorry, I need a little bit more. Next step would be function pipelines and integration.
Would be working on function pipelines and integrations.
So our next steps are to work on integration between Wikidata and Wikifunctions to be able to access data from Wikidata in Wikifunctions, and then to integrate the Wikifunctions results into the Wikipedia and other projects. That's the questions. And yet the pipelines on how to exactly do this and where caching happens, when the things get updated, how do we recognize that something in Wikidata has changed? This will be a big part of that, which will be happening behind the scenes, and hopefully just magically work the way we expect it. But yes, this is definitely the next steps we're working on. I hope I answered the right question.
So now it's time for a wise woman to. There you go.
Okay, thank you. Thank you, Denny. Again, it's a brilliant thing you have that I don't understand at the beginning, but it's beginning to make sense. I think it's a great idea for replacing things like the module for age or something like that. But to have it generate content, my problem would be that the databases that you're using for generating these lists, the lists are wonderful. And I use Wikidata a lot for getting lists of potential things that I want to be looking at. But there's so much missing still in Wikidata. And I would be a little bit leery of Wikifunctions generating lists like this and people thinking that this is the true and one and only list. And as you've shown very nicely with your dinosaur example, that's a brilliant example. It's kind of hard to sort this kind of thing out. So I would want you to have some sort of a caveat at some point to say, well, this is not the one and only list. This is just a little bit of the list. Or how do you see this developing? Do you think Wikidata will at some point be no longer biased?
Wikidata will always be biased, just like every representation of knowledge necessarily has to be. But what I would see here is that if an editor starts putting content that is generated through a function call into a Wikimedia project like Wikipedia, they would actually check the result at that point, and then they would hopefully notice that there's something missing and so on. So I'm just as if someone creates, if someone, for example, starts replacing the list of states, of US states in some place and the capitals or whatever, I would very much expect them to take a look whether the list is actually complete. Are there 50 of them? Are they any repeated and so on? And if they don't do it, I expect other contributors to pass by and say, wait, this is wrong, and start actually either fixing the data or telling or just reverting the thing and say, come back when it's complete. So the nice thing that we have is we have all these communities working together. So even if an individual person is maybe a little bit less careful, we have the community as a whole to do the editing work and see, no, look, this is not complete. We have to either to write this manually because we can't make it complete in Wikidata, or we have to go and first clean up in Wikidata before we can actually do this here and replace it.
I'm not as optimistic as you, because I see so many people believing everything ChatGPT says and not bothering to check it. So, and especially if we have less and less editors working, like we have the problem in the Wikipedia right now, that might cause a problem in the future, that we don't actually have that community anymore. We rely on functions.
Here the hope is also, so it's true that a lot of people seem to believe a lot of things that ChatGPT says, but it rarely makes it into Wikipedia. It doesn't stay unchecked there, I hope. I don't hope that there's too much content being just taken as from a ChatGPT result and then not being carefully edited out or being checked for correctness, just like with any other contribution, right? Regarding the number of contributors, in fact, Wikifunctions is a little bit of a remedy in this direction, because right now in every in every language edition, the contributors are more or less within their language community. And with Wikifunctions, the idea is that those functions can actually be available to all of the language editions at the same time. So we would then grow from, let's say, about, I don't know, 3,000 or 4,000 contributors on the curation Wikipedia to potentially 2,000 contributors across all Wikipedias working together on a specific function. So even without growing our contributor base, we have more people working together on the same content, basically. So I hope that this will kind of counteract this this very realistic fear that you're describing.
Okay, we are already over time, but there are two more questions that I would like you to ask to answer. One is, right now, a lot of Wikidata functionality is from user Peter. Right now, a lot of Wikidata functionality is done with bots. That's a problem. Can Wikifunctions take the place of bots?
Partially, maybe. So Wikifunctions themselves won't do anything. You will always have to go through some process of saying, okay, I'm calling now this function, and then I'm doing something with the result, like storing it somewhere or whatever. So it won't replace it in many cases, what bots are doing. In some cases, part of the work that bots are doing can be replaced. Less so for Wikidata, actually, more so for the Wikipedias. My hope, for example, is that something like LSJbot can indeed be replaced mostly with Wikifunctions, and therefore putting it back into the hand of the communities to control the content that they have. Instead of having materialized texts in millions of articles that are only editable if you have access to this bot, it would be part of the infrastructure and anyone can click on edit and change pieces of that. So something like LSJbot, I hope, can be replaced. So a lot of the other bots, not necessarily. It really depends on the actual bot that we're talking about.
Okay, so last question, which is probably a pretty straightforward answer anyway. When will Wikifunctions be callable from other Wikimedia projects?
I have a very clear, I don't know for that yet. We're having major discussions because part of our infrastructure isn't really good for that, about resourcing this part of the project and so on. I can't answer this question. I don't know. I would love to be able to point to the community and say, look, there are a lot of people asking for that. Can we please resource this sooner? So if anyone wants to organize something like this, I'd be super thankful, and it would be very, very helpful for me to get this thing done sooner. Currently, I can't give you not even an estimate. I'm sorry.
Okay, thank you very much, Danny. your presentation and for your answers. Thank you very much for the participation to you all. Thank you very much. Sorry to Rory O'Donnell for butchering her name. I'm so sorry. I apologize for that. This ends this part of the session. So we will reconvene in 10 minutes because there is the last panel of this day, which is from Mahir. And see you in 10 minutes. Sorry to interrupt, but brief reminder that in 3 minutes there will be the last session of day 1.5, Building Abstract Wikipedia using Wikidata Lexemes by Mahir Morshed. And see you in 3 minutes. All right, it's time for us to start again with the last panel from day 1.5, Building Abstract Wikipedia using Wikidata Lexemes. The speaker is Mahir Morshed, also known as Mahir256, admin on Wikidata, and one of the users that is most involved with Lexemes among the Breton users and others. And well, Mahir, now the floor is yours, please.
Okay, thank you. It is great to be here. I'm sorry I wasn't able to make many of the other sessions before this. I had a busy day today, but I am here and I'm happy to talk about this topic, which is something that I am trying to actually realize instead of waiting for Wikifunctions to reach a point where I can just do it on Wikidata or on Wikifunctions itself. So first of all, why do we want to build abstract Wikipedia with Wikidata Lexemes? Why do we not do it with other things that work with strings or things that are very ad hoc, if you will? So first of all, the idea is that if we want to improve the output from the system, we should improve Wikidata. There's no free text that's involved. There's no string injection, so to speak. If you want to improve anything, you need to improve the Lexemes that are involved because Lexemes represent words and phrases and concepts, and we're trying to combine those concepts into a coherent whole. At the same time, the underlying functions that power this, are essentially based on rules. They're based on grammars, most likely, and trends that can be referenced, that can be codified in some form. And so the idea is to turn those rules into functions, hopefully Wikifunctions in the near future, but functions nonetheless. At the same time, when there is an ambiguity in the output, we want to be able to also figure out, okay, what does a part of this output actually mean, and where in the abstract content that we're trying to define does it come from? Where does a particular part of the output originate? And most importantly, and actually something that I'm trying to work on starting this week, is to make it hopefully easier to add to in terms of adding new languages, adding new constructors for abstract content, adding ways to turn that abstract content into sentences, if you will. There's a nice technical description of under review of how the system sort of works on the back end, if you're interested in that sort of level of technical detail. But these are basically the gists behind what I'm trying to do. And again, just to go through the process of how we actually build abstract Wikipedia with Wikidata Lexemes, we're first going to need some abstract content, and then we need some lexicographical data as sort of two ends of a contribution sliding scale, if you will. And then you go back and then you add constructors or define these things, and then also functions to form sentences, do things with putting words together, putting morphemes together, if you will, as again two ends of the same sliding scale of contributions. And then somewhere in the middle, there needs to be a way to directly interface abstract content with these functions that put together sentences, and those are what are called renderers. And then once we have all 5 parts of these of this scale implemented, then we can render something and then maybe profit from it. I don't know. We'll find out. This overall system has several parts, which I've given names to for the most part. There's this first part, Ninai, and which turns abstract content into syntax trees, which are basically these diagrams of how a sentence is structured, if you will. Udiron is a similar tool, except that it turns the syntax trees into strings of text like the ones I can select here. There's an underlying library which I've developed to make accessing Wikidata in Python very somewhat more straightforward. And actually, just as a heads up, all of this is implemented in Python right now, for the simple reason that in the future, once Wikifunctions is developed up to a certain point, this software, like almost verbatim, can be essentially ported to Wikifunctions. It can be turned into Z objects for various functions, implementations, objects. It's being designed sort of in that way, which may or may not conflict with the idea of making it easy to contribute to, but that's a discussion for a different day. So to go through these steps sort of one by one, we should first talk about creating abstract content, essentially. How do we do this? There's also the question that recurs is, how should it look? One way that it might look is sort of like this, where all of the abstract content is essentially different nested lists of Q items and possibly other strings, such as this date, which appears in the string right here. But that's very daunting. It's very daunting to look at right now, and I'm not endorsing that it should be looked at this way. More on that towards the end of the session. But if we translate these into at least English labels, we're going to get something like this, where each of these items is used to represent a particular concept, which, if it starts with an open parenthesis, it's assumed to be a constructor, as in we're defining, for example, a predicate, or basically a sentence, if you will, using this constructor which has the name predicate. We're defining a location inside of which something is happening using this thing called inessive, and we're defining, when something is occurring using this thing called timestamp. But underlyingly, these are still, Wikidata items that are used to represent these things as names. The idea being that you could take this representation and then translate all these items into French labels, and then a French speaker should have some idea of what this is doing at the same time. You'd get something like this. And actually, in the Python code, if you were to do this entirely in Python, the thing you would use would look something like this instead, where these capital C constructors are actually just sort of like functions. And if you've ever used the composition syntax in Wikifunctions, this should remind you of how that syntax looks. All it is just nested, functions upon functions, which is sort of what inspired the notion of abstract content within the system in the first place. So that's essentially what we're going to look at. And we can, if we had more time, we would likely want to talk about how do we define our own. We're talking about what kinds of other constructors might we need. But that's very much a mental exercise meant for when you decide to design a way to model abstract content, you're gonna need to think about, okay, what kinds of abstractions do we need? So that's essentially what goes into this. Once we have these capital C constructors, though, we can go to the other end of the contribution scale and just improve lexicographical data. Those of you who contribute to Lexemes and already do this, very good for you. I'm very happy about that. But sometimes there's information about these things that it's worth pointing out that the information that's useful for abstract content generation or content rendering purposes that's very useful throughout this entire process. So, for example, we have a noun with 2 meanings. We link these meanings using a property called item for this sense, where the item for this, where the Lexeme sense meaning like soul is linked to the item for soul, and the Lexeme sense meaning heart is linked to the item for heart. It's also linked via synonym and translation to other Lexeme senses, so that even if we don't know what the specific Lexeme is for the word meaning heart in your language, if they're linked to the same item, this is the item for heart, of course, then we'll still be able to get from a Wikidata item to a Lexeme sense with the same meaning as heart. That was the idea behind the last bullet point in the main parts of the system, which is a tool to go from items to Lexemes. And if you look back at the abstract content, all of it is Lexemes for the most part, or is items for the most part. Very few Lexemes used in that abstract content. Another thing that can be sometimes useful is to distinguish, the semantic gender of a particular entity if the item is not so distinguished. We have an item for a loved deity, but this particular Lexeme in Estonian has the specific semantic gender male, female. I guess I used the wrong item here, but there's the equivalent for a male deity is marked as semantic gender male. Maybe these aren't the right semantic genders, but that's a question for a different day. Similarly, if a lot of languages which are spoken in various places have specific locations where a particular sense is used. So this is a Lexeme sense for a bread roll, which is used in a particular part of Sweden, and it's marked this way. See, even in English and German, there are lots of Lexeme senses for a bread roll, which are used in very different places. I have never heard these things used in the United States, for example. Similarly, we could also make distinctions between, in the event that there are languages that are treated as separate entities in different places, we can say that, okay, this particular word for January is used in Iran, whereas this particular word for January is used in Tajikistan. And I believe these have different derivations, one from Russian, one from French. So that would be semantic information. Syntactic information is actually very important because this is how we're modeling ultimately the functions that are used in the system to produce these sentences have to sort of yield sentences in a very similar fashion. So basically what I mean by that is we have something like climate activist in Swedish, which is composed of 2 parts, climate and activist. There's a relationship between these two, which we've marked with this particular qualifier. And there's a number of other Lexemes here which are marked this way. More activists, refrigerators, the verb for to love in Korean, and the verb for to request in Persian. Each of those is marked in terms of its syntactic relations because these relations are essentially what drives the production of sentences in the underlying system. Even for Cantonese, we can do this on a character basis. And for verbs, actually, sometimes this verb can have multiple meanings because one of the parts of this verb has multiple meanings, and we can specify the meanings that are used here by, well, first of all, we can use this predicate for relationship and see how it aligns with the item for the sense relationship. But also in a Lexeme sense, like to request, we can make it explicit that the meaning of this first word in the verb for to request is this specific sense on the verb for to request, or in the word for request, where you see we have a link back to request, and this is the predicate for request. That is the case because this lexeme it has the meaning request. Being able to specify these things, the more things that are specified in lexemes, the better. Hence why I state that to improve the output of the system, you have to improve Wikidata. And just to make it very clear about how much syntactic relationships are important, this is an entire proverb lexeme. It's basically a sentence. So conceivably we could get something out of this from the system as a whole. But we see that every one of these parts is marked for syntax, and we get a nice little tree out as a consequence, where this is ultimately a sentence about I guess slices that fall, and whoever plans or whenever plan is made, slices will fall, or something like that. Sorry, I don't speak German and I forgot what this meant. But this is true for a number of other languages as well. Here's a Turkish proverb where not only the words, the base words, but the individual morphemes. Like it's a very suffixing language, and so each of the suffixes has a lexeme that's linked to this. So that information is actually very important and will be very useful. It's a useful thing to know for the following slides because, well, we have the following parts of this presentation deal with Turkish because it's an interesting language to try to clean up so that looking at the code, it'll be easy to understand what's going on. First of all, we need to add some constructors, and we can talk about, okay, how do we define some? This is where this slide comes into play. Please don't fret. Basically, the idea here is that we have something like there are exactly 3 lines that you actually need to define your own constructor, and this part is just documentation. Basically, we're saying that this constructor means that the concept that's inside it, we're talking about being inside that concept. So I am in the park, for example, or I walk into the park in the case of this relationship. And really, there's nothing else to it. You're basically, yes, shavings, chips, splinters. Thank you, Nikki. That's good to know. But honestly, once you have these constructors defined, you're done, and you could use them to define abstract content. We can do this as well for very specific, sort of meta relationships, if you will. So if we want to talk about, I, you, or we, or they, we could define constructors that resolve to this, or that should be resolved to something like that. And they would be just defined in exactly the same way. Now, once we've defined constructors, we need to add some functions to sort of edit the syntax, actually put the sentences together and modify them if need be, depending on what other information we have. And honestly, like when you look at the code for the Turkish functions, there's really here. This is actually just like 2 lines of code. This is a definition and then a single line. And most of these functions are kind of like this. This is all just documentation, just to let you know, okay, what's actually going on. And I'm trying to be a bit diligent by in designing this by specifying, okay, where am I getting this information from? This happens to be a grammar that I'm reading, which has been very helpful in making decisions one way or another about how to do things. And a lot of these other functions, like this, here's a function that adds a suffix to a lexeme. Here's a function that marks a particular case, and a function to check whether a lexeme has that case. And yeah, most of the functions here are pretty simple like that. And in principle, once as time passes, other functions that will be used for working with syntax trees in your language will be similarly simple, hopefully. Now, once we have these syntactic functions, okay, we need to add some renderers. The renderers, again, are the parts that take the abstract content parts and then use the functions that put sentences together, essentially. So when we go to this list of renderers, we actually don't have, there's at least 3 lines that we need to define. And the only things we really need to specify are, okay, what language are we rendering into, and what's the name of the constructor that we're trying to render. And we see that some of these are pretty short, and then there are others which can be a bit longer, but are at least fully understandable from just looking at it. So here we're trying to find a sense for this Turkish word meaning inside. We're trying to mark it with the genitive, and then we create a postpositional phrase using that word, and then the particular object of the postposition that we retrieve from somewhere else. And there's more to that in the technical description that I linked, and I can probably link again if so desired. But essentially, the renderers are also going to be very simple to write. And there are actually functions that are needed to turn the syntax trees into strings. Depending on your language, those could be very simple. You know, if your language is very isolating, like Mandarin, or I guess Thai does this as well. But if your language is like Turkish, where lots of combinations do very different things because of how the sounds work, then those functions might be a bit more complicated. But hopefully, those will look a lot less so in the near future. Once we have these things defined, we can try rendering this abstract content, and this is where something I'm really excited about is I can finally unveil. This is essentially a front end hosted on ToolForge for the system that I've designed. And you can see that if we go back to I guess what slide was this? Slide 5. You'll see that this is the abstract content that I mentioned before, and that here Q1966626 that is the abstract content for context, and for Q179080 that's for predicate. And again, all of these for the most part resolve to essentially items, if you will. And we can modify each parts of this, as much as we want. We can say instead of using liquid water here, we'll use refrigerator. And then again, basically this abstract content is the same thing as I showed in the other slide. We can choose a language to render to. Again, right now we just have Turkish. We can copy a link to this abstract content, so that if you wanted to mess with it yourself, you could totally do that. And then when we click render, we get something out. It takes a bit of time because there's a lot going on, but we see we have a sentence which I believe translates to I will give you the refrigerator in the suburb of Galata. Galata is a suburb of Istanbul. What's actually really fascinating about this is that we don't actually, and we're talking about a refrigerator, but there isn't a Lexemes meaning refrigerator in Turkish. So we're actually generating one from the words for snow and cabinet here, because, and this is where I will go back to one of these other slides. If we look at the Lexemes for refrigerator in Cantonese, we see that it's a compound and it has these two parts linked this way. And these two parts have different meanings, where the first part means snow and the first part means cabinet. And so because Turkish doesn't have a Lexemes for refrigerator, we're just making the word snow cabinet because we can. Maybe your language has another, compound for refrigerator which has where the parts have different meanings, and those parts can be used as well, assuming that the parts have Turkish meanings as well. And again, these outputs can be analyzed. Okay, which meaning of this word are we using? It's the second one, and most of these I think only have one sense, so we're just using the first senses of each of these. But if Lexemes has multiple senses, then we can see, okay, which sense are we using, and which inflection are we using too. Some of these are marked for different cases, like nominative and dative, and so on and so forth. And actually, both the verb and some of the suffixes can be marked for things like, person and singular, depending on what we specify to be, the subject, and or in this case, we're using more general semantic relations like agent, patient, and so on and so forth. So that's basically it. That's basically it. And I'm happy to take questions. I've gone through a lot very quickly, but I'm happy to take any questions.
Thank you, Mahir, for your presentation. Is there anyone that wants to raise their hand or ask a question in the chat? I saw lots of comments, but no questions for now. So.
Okay. It's still very much under development, and I do want to add more explanations of how things work soon. My hope is that I won't have to do as much to add stuff for other languages as much as you can do that. That's again an explicit goal that I'm trying to work towards. And I think shorter functions and more explanations are a way to do that. What can people who don't program do to help you? Yeah. So basically, the step 0, I guess, which I've marked here as improve lexicographical data. And by improve, I don't mean like there are some language communities which are just adding lexemes without even senses. And while that's an improvement in one sense, the ability to use that information in generating natural language is very difficult because there's a lot of cleanup to be done. There's and even if your functionality is tolerant to those kinds of differences in how you model something, that can end up being very difficult to reconcile later when you need to add new functionality or there's some information which is just entirely absent in terms of how something works. So honestly, just ask. I am available as not as this, but although I will probably improve. I will probably respond to questions on this. Yes, would love to see more demos on context-based languages. It's a funny story. Yucheng, I was thinking that if I had more time, I would try to add support for Cantonese live. That's sort of why I had the refrigerator lexeme made. So that and also I think I added a few other lexemes as well. Yeah, I wish I had more time before this to add support for things like that, but at least in terms of lexemes that we do have, we could make something like I guess here's we. I thought I had to eat someplace, but maybe I'm mistaken. Yeah, here's to eat, and then I guess here's beef, and then where is the past marker or perfective marker? So in principle, I would love to have generated a sentence based on something like these 4 lexemes, or done something more complex, but alas, I've not found the time to do this, and I still need to write up more explanations so that hopefully you can write something like this for Cantonese or Minnan or whichever language you speak. Yeah.
Sorry, I was muted.
Mm-hmm.
There's a question from Tuka, just came in now. How does this progress on abstract Wikipedia compare to the similar GFpedia demo by the grammatical framework?
That is a very good question, which I could answer at length, but I'll basically say this. This GFpedia thing, which you mentioned, does not rely on Wikidata lexemes, first of all. It does not rely on the ability to add to this system requires you to learn basically an entirely new language, so that even those who are able to program still need to learn this language to make things work. And third, it's difficult within the system to within that system, as far as I understand it, to add references to how things work and to improve upon it in a sort of real-time fashion, if you will. Whereas at least what the system that I'm trying to build is set up so that you could there's a part that has to remain up. That's the part that that would be this part, which tries to go from Wikidata items to lexeme senses. While that part is active, the rest of it can be designed sort of live. In principle, you could do this on Wikifunctions if all of these parts were ported. Whereas with GFPD, I don't believe that it is possible. At the same time, I guess one last thing I could say is that the notion of abstract content is very much driven by community members. They could, again, define their own constructors in a very simple fashion, and then for their languages, define renderers that that actually do something with those constructors. Whereas, as I understand it, the sort of layout of a GFpedia article is very, very fixed. It's very much not something that you could change very easily, as far as how abstractly the information represented in that article is. Whereas with with this system, you can even add, like, this is actually not this is actually just controls the tense of this verb here, where according to the time, and you could specify this in the abstract content if you desired. It doesn't have to be realized as a word, but it does appear as an effect for other applied to other lexemes. Does that answer your question, Tukka? I do want to work on Finnish at some point. There are enough lexemes of Finnish that I could try to do something with that, and I do want to do that at some point in the future. Hi, Nicola. I can't hear you, Luca. Still can't hear you, Luca.
Sorry, again muted. I'm sorry. It's just too late for me. Anyway, thank you very much, Mahir, for answering. Thank you very much, Tukka, for the question. All the people here for their questions. Since people are already leaving, I would like to give them a good night too. But we still have some more, couple of minutes left. So if there are any more questions, please let them come in. Yeah, there's a Hugo. I saw that they are going to ask something.
Yes, now I have time. Now I
Go.
have time. I hope it will now work as I switched on the Wi-Fi again, was automatically switched off at 0 p.m. now. I have a question about data, the data structure, because what I have think about, and you showed that too, so do they make then many API requests if you need different Lexemes forms, for example, or have you think about how far it is possible? As I think at least most of the Lexeme data should not change regularly after it is constructed once, to have kind of a local dump in to integrate in the tool, so that then no API requests to Wikidata are necessary.
As far as how Wikifunctions will deal with this, that is a question for them. With respect to the implementation that I'm using, with respect to LMWALA specifically, so whenever a Lexeme is retrieved in LMWALA, it's cached for about 5 minutes. Although you could adjust this time period depending, like if you downloaded this yourself and tried to run it yourself, you could change the amount of time that things are cached. This is true of Lexemes. For the actual graph of linkages between Wikidata items and Lexeme senses, that stays in memory a bit longer, and mainly because you have to rebuild the graph each time that you introduce a new sense relationship between a Wikidata item and a Lexeme sense. So I wouldn't say, and there are no requests to the API on Wikidata for trying to find those linkages, because, well, there is no API for that. But the concern you have is warranted, and that's why there are caches that are in place, so that Lexeme retrievals do not take up too many network requests.
Thank you, Hoku, for your questions, and thank you again, Mahir, for answering. We are we are over time, not way over time, but we are over time. So thank you everyone for this for intervening. I now cede the floor to Leah for closing remarks for day 1.5. And thanks again for joining and just be with us.
About to have a break for a few hours, but because this conference is running almost all around the clock, day 2 is actually going to start in a couple of hours, broadcasted directly from the University of Taipei. So if you're still going to stay here for a little bit, you will see the beginning of this program. We're going to have a lot of interesting sessions, both from speakers from the EASIAP region and also from other regions. You will be able to see to watch the content here and also on YouTube. Unfortunately, the ones attending in Taipei will have cake without us, but that's fine because you may also want to join or one of the birthday events that are organized in your region. And then we will continue with day 2.5, which will start, well, the schedule is displays it at 3 p.m. My time, but if you go on pre-talks, you will see it appear on your time. And we're going to have the Wikidata birthday present lightning talk. So if you want to present there, don't forget to add yourself on the pad. And speaking of time, for people like me who are based in Europe, don't forget that we have the time change during the night. And this is why we're going to start at 3 p.m. But don't worry, pre-talks is also pretty smart and it's going to display the new time for you in the schedule. So I think that's it. You can, of course, hang out here a little bit more. The pre-talk, the GatherTown platform stays open all the time. Thank you so much and see you later at the WikidataCon.